This is the Amp Hour Podcast, released November 1st, 2020. Episode 515. Embedded Linux with Jay Carlson. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Jay Carlson of jcarlson.net.
All right, well named, well named. Hey Jay, how are you doing?
I'm doing great. How are you doing, Chris?
I am a bit flabbergasted. It's been a couple days since this article came out, but you released the, so you want to build an embedded Linux system, and I'm still crunching through it, to be honest. It's a work of art, I gotta say.
Oh man, it's 37,000 words. So
is it really?
Yeah,
oh,
wow. it's gonna take a while.
Yeah. As I mentioned on the last show, Dave and I were talking about it, and I sent it to my Kindle, and it was like a small book. I mean, like it's pretty much half a book. You're pretty much halfway there. Why not just write a book?
Ooh.
I mean, I guess you did, sort of.
Yeah, I sort of did, right?
Why not sell it to a publisher, I guess?
Well, I don't know. I think the main thing is it's nice to just work on projects that you want to work on at the schedule that, at the pace that you want to work on them. I started this really like Corona, I would say, is like, it's been my Corona project.
Okay. Yeah.
And so it was just, it's going to be done when it's going to be done, and you had messaged me a little bit and wanted to do an interview at some point.
Yeah. Well, what I alluded to last week too was I begged you not to go back on Embedded before you come on here, because I knew something was, I wanted to talk to you about like learning and all the, first off, those 2 episodes were amazing. I refer people to them all the time, but I wanted you to come back on here before Alicia and Chris got back to talking to you, because I was like, come on, like I get to talk to him.
Yeah.
He does a lot of hardware.
Well, and they just talked to Drew.
Yeah.
Drew Festini, right?
Yes.
And he does, he's does a ton of embedded
right.
Linux stuff. He does it more from like the software side. So, I think hopefully they are full of embedded Linux for the time being, and we can circle back later on and talk to Elisa and Chris.
I mean, there's a lot here. And so Drew works on BeagleBoard, and I know Jason and Robert from BeagleBoard, and they've been on the show and stuff like that. And that was actually one of the episodes where it started clicking for me. Like, I've had a long time where firmware and software has kind of been a tough kind of mental model for me. But something about that episode, like you can kind of hear me getting confused and then kind of getting less confused. And that one was like a big episode for me for some reason.
Chris, I've been doing this for years, and I'm still confused about that stuff. So yeah, no, it's super weird because, Linux is one of those things where, we've all tried running it on our laptops, right? On our computers. You've got an old computer. I was going to say an old 386 or 486
with a turbo
or
button.
an old Pentium, or I guess I don't know what the equivalent is these days. My friend Charles just dumped Linux on an AMD processor from 2006,
Wow.
and it works great, right? And so I think a lot of people, a lot of hobbyists and even engineers, we have experience with Linux. We've sort of played around with it a little bit. What really does it mean to first of all, like, what is an embedded Linux system, right? And so I wanted to kind of hit that. What's interesting though is I think so much of this content out there is geared at people who are software people, like Linux software developers. Yeah. It's like, oh, well, how do I make an embedded device, given the fact that I know how to write software on Linux? What I wanted to do was approach it from, all right, I'm a hardware, like I'm your classic electrical engineer, right? You're old gray haired, I'm not that at all. I'm like 30, 33, but like how, if I know like PIC16 and I do PCB design and I can write, a little bit of C code, some firmware, how should you go about looking at Linux if you're starting from that, right? So I tried to kind of approach it more, and in terms of like the stack, it would be really BSP stuff, board support package stuff.
Yeah. And I think that's one of the things that always kind of confused me too was, okay, so we're at this, I have this high level concept, like, yeah, of course, Linux, I'm on a Windows system, Linux system, whatever, like it's running on hardware at some point. but I just don't think about it. Like, it's just like it works or doesn't work. It's just this, it's this thing that makes a screen go in it. And then my brain turns around and I'm like, oh, look, pretty pictures and like that. And then like, as long as it's working, I'm happy. But at a certain level, someone's writing that support for the next x86 or the AMD or whatever's out there. And that's kind of what you're talking about here. You're talking about writing that interface down to the lower levels of hardware, right? And getting at the peripherals and getting at the display interfaces and the memory interfaces and all these things that are on every chip, but now need to be customized for a non-traditional chip, like, well, not even non-traditional, but like a embedded chip like this.
Yeah, yeah. Well, and what's funny is I hope like one of the big takeaways is, I've been working on this project on again, off again for, 6 months. I designed 10 different boards. Generally, it took, for most of these parts, it took, I don't know, 3 hours on the software side to boot them up to a prompt, So like, I think one thing is like, people need to understand that all this stuff, I tweeted a few weeks ago, the difference between, bare metal C development and embedded Linux development is, in bare metal C, you spend all your time writing lots of code and, reading documentation, right? Reading register maps, reading, whatever. On Linux, it's the opposite. I feel like all I do is read source code. Like, seriously. And
Yeah.
it's super funny because you don't, it doesn't matter. I've got a one project I'm working on, basically getting this crazy MIPI camera sensor thing working at, 1080p, 60 hertz, streaming, 2-lane MIPI at 800 megabits per second. And I've got, it's all 10-bit raw data. So it's got to go through a ISP to demosaic it and do color correction and all this crap. And, you're just reading through code, and you're just, I don't know that I've written really a single line of C code, right? It's more about just like reading code, configuring, doing DTS stuff, device tree stuff. And yeah, I don't know. So
and that is where you actually do the hooking up, right? Is in the device tree. That's like kind of that's the answer key for, needs to talk to SPI or needs to talk to MIPI or whatever.
Yeah. And we're bouncing all over the place. I mean, if we want to like talk about from kind of like a logical perspective, right? Like if someone's like, explain this to me from start to finish, right? First of all, what you have to think about is like Linux it's this operating system, right? Which is fundamentally not that different from, FreeRTOS or Zephyr or anything like that. But one big difference with, it would be more similar to Zephyr, I guess, in the sense that it has drivers for everything, right?
Right.
So, let's take a really simple example. Let's say you've got an accelerometer hooked up to your I2S bus on a microcontroller. Well, Chris, what code would you have to write to get that to work?
I mean, it depends on if it was like a small microcontroller.
Yeah, like a little microcontroller.
Yeah, get like a I2C library, or in a worst case scenario, write my own library to talk to the actual I2C registers.
On the processor, yep, to configure the I2C.
Yeah.
On the actual microcontroller. Yeah. And then also, you'd have to have a driver for the actual accelerometer itself, right? So you have sort of like, you've got a driver for the bus, and then you've got a driver for the chip, right? And so, Linux is going to be no different than that, right? So, if you've got a Linux process, some processor running Linux, you've got a I2C bus driver, and you've got a sensor driver, and, they really don't look that much different either, And really, at the end of the day, Linux is just the kernel that's scheduling tasks to run. I mean, to be honest, it's quite simple.
Yeah, I feel like the term driver as well is a, for a long time I thought of it, like when I used to think of drivers, it was like this thing that I install, the DLL that I install on my Windows computer, and it's this thing that just makes the hardware work, or it needs to be updated. But at the end of the day, it's basically talking down to the registers that are in that thing that I'm plugging in there, and it has to make sure it knows which registers are where.
Yes, exactly. And, and I think one interesting difference about Linux is, you have different object files, right, that are sort of inserted into memory space at runtime, which is very different than a microcontroller. I mean, so Linux itself, VM Linux, right? The kernel, it's this file, right? That your bootloader, U-boot typically has to basically read this file either off of a SD card or off of, flash memory or whatever. And it reads it into RAM at some location. And it literally just sets the program counter, PC equals whatever address it dumped this file into. And it starts executing,
Wow.
I mean, and if you think about it, like then Linux, right, it needs to, so, some of the drivers are built in, so they're compiled into that main kind of object file, but then you also have loadable modules, right? I mean, you can certainly build a Linux module as like a .ko file. If you've ever seen a ko file, that's like a kernel module, a loadable module. And so that lives on a file system. So, I mean, there's some chicken and the egg problems, right? Linux needs to have enough modules built in to like, know how to talk to your MMC, your SD card, and it needs to have a module to know how to talk to the fat file system and all that stuff. But once it does that, then it could actually load a module out of a KO file, right? It takes that KO file, reads it into RAM, and goes ahead and runs the probe function and, does all that stuff.
Yeah. The one thing that might be helpful to disambiguate for listeners as well is like an object file is the output of a compiler, right? I mean, that's like the subsection of code. So if you have a, spy.c and that's, the code that runs the spy, well, maybe that's a bad example there, but, you have some file that .c.h is associated there, it will then create an object file that is the compiled down version. Right?
Yeah. No, it's actually, I think that's a good example. So imagine that you had a spy.c file that had a function named probe, right? And, maybe a function named read and a function named write and a function named ioctl. Right?
This sounds like POSIX or something.
Yeah.
Huh?
Yeah. Well, that's exactly what it is, right? So imagine that you had sort of these predefined functions in that C file. You could imagine compiling that into, it's not just an O file, right? Because we need to have some metadata so we know where those function entry points are, right? But that can be sort of put into like a header at the beginning of the file. And so, you have that well-defined format, and all of a sudden, if you had like, I don't know, some super basic microcontroller running on free RTOS, some very basic RTOS, you could imagine reading that file off an SD card, right? Loading it into RAM, and then basically just casting those offsets as like function pointers basically and just calling those functions, right?
And say go to this location and you get this new capability. It's like a magic spell.
Yeah, exactly. So I think when you get into the mechanics, I feel like I think one problem is like people are afraid to get into the mechanics, right? They want to stay super high level and they want to talk about things conceptually. But like, right now, you and I, we're just kind of getting into the mechanics of just loading files off disk into memory, executing stuff. And really all those concepts, they all work together to form, how modern operating systems are built. And Linux is no different. Now, the funny thing is you really don't need to know any of that to be completely honest.
Oh, thank God.
So, I mean, let's just take a simple example. Let's say you grab, I don't know, pick a part from my review.
I like the all-winner ones because I see those in like the A33. How about that?
Yeah, the A33. All right. So A33 is a great example because it has like it's just plug and play. I soldered this thing to the board, to a PCB with some, chunk of DDR memory on it. I plugged an SD card into it. I turned it on and it just booted right up. Right. So, and so what you want is you want to find those chips that have good, and I would say not just good Linux support, not just good, U-boot support, but like good, like build system support. So when we're talking about build systems, we're talking about either, build root or Yocto would be the two big ones. There's also like, Open WRT and there's some other ones too that are more specialized.
We're going to have a lot of links here, but the basic thing to know is that if you want to know about any of this stuff, it's going to be jcarlson.net/embedded-linux. That's going to be like all the things we're going to be talking about here are going to point back to that pretty much. So people can always just go search that. I do recommend reading the whole thing multiple times on a Kindle. You'll still have some questions, but
yeah. Well, and when you do, I'm pretty active on Twitter, so hit me up and get some discussions going. But yeah, I mean, so you fire up build root, you configure the def config, you make it, and
Uh-huh.
hey, it's going to pop out an SD card image that's going to work, and it's going to have everything pre-configured for you. You're going to get a SD card, you boot off of it, and then what you end up doing is you just hack it, right? You add a driver, you
Yeah,
make some
yeah.
changes, and that's just the best way to learn all this stuff.
That's great. So the step before that though, so you would go to like an all winner site and you just download like a package there. What does that look like? Is it just like a tar.gz or something like that? Like just a zip file that
No,
okay.
it's even simpler.
Okay.
So the A33 has, like mainline support or whatever you would call it
Mm-hmm.
in build root. So you literally,
Okay.
like the official build root project. I mean, they have a Git repo, and you literally just clone the Git, and it's, you can use the Olinuxino. So Olimex, they have an A33 dev board called the
Yep.
Olinuxino. And pro tip, as long as you make your board kind of similar to a EVK, you
Mm-hmm.
can basically just steal their def configs for everything.
Yep.
So as long as you have an SD card hooked up to the same pins as the Olimex
Yeah. Yeah. Yep.
A33 Olinuxino board, right? You just
Yep.
steal their def config. It's honestly, it's just like an Arduino, right? If you take
Yeah, or I mean,
eight
any dev board, right?
any
You're going to
board,
start
any
from
dev board,
something like
yep,
this, right?
yep,
And then I think when you start swapping pins around. I learned this from my friend Eric, who I've had on the Contextual Electronics podcast, and like he he would always be like, "Chris, why did you move this pin? It doesn't make sense that you
yeah.
did this." And I'm like, "Oh well, I just thought." He's like, "Just do it. It just why would you do this? It doesn't." And like it was always a good idea just to because then you have this great like sanity check. Maybe you've bought an Olexino board or you've bought whatever dev board that you're basing it on. And you just go and check it, and you're like, "Oh, the pin's high and mine's low, and something's wrong."
Well, and like, when you're doing like kind of, solo engineer, one man band stuff,
Mm-hmm.
right? The PCB designer inside of you is constantly fighting with the firmware guy inside of you, right? And there's like right, because the PCB designer says, "Oh man, it's gonna be so much easier to escape that
Yeah,
pin
I'm
if I
gonna route that
just
pin
move
there.
it
Oh
over here."
yeah, that's yeah.
Because it's like it's always that one, that TX pin that's like
Mm-hmm.
4 rows in, on a BGA grid, and like you can barely squeeze it out on a 4-layer stack up. So it's, God, I'll just move the default UART, right? I mean,
Mm-hmm.
like it can't be
Mm-hmm.
that bad. And I did that, and then you start to realize that I will say, once you've done your first board, do another one and like intentionally screw it up, like force
Oh,
yourself to use a
interesting.
different UART, because like, man, that's such a great way to learn like where everything is, right?
Yeah, right.
So you change your default UART, right? You've got your console UART. All of a sudden you've got to go into the U-boot source code and change that default UART, and so
Oh.
all, it's base address, and it's, and the device tree, the pin muxing, right? All that sort of stuff. And then
Mm-hmm.
what's funny is, you'll get U-boot working, and it'll, press any key to you can type boot. It'll say starting kernel, and then nothing, blank, black screen. It's like, what's going on? It's like, oh yeah, Linux itself needs to know about the console UART, right? And so, then you sort of set up Linux to do that, right? Which
Mm.
can be, boot arguments that U-boot's passing. You can set up Linux to have default boot arguments, lots and lots of different details there. But it's like,
Yeah.
that's how you learn this stuff. You make mistakes and then you work through them.
Yeah. Yeah. That's great. One thing that's interesting to me, and is you're on a hardware podcast pretty much, and so my co-host Dave does not really do Linux. So do you have any? And you're a teacher as well. So what happens when a student comes into a class that you have taught or do teach, and like doesn't know Linux? What do you tell them then?
Like, doesn't know how to use Linux?
Yeah, exactly.
Oh, I tell them to learn how to use Linux.
I meant more like resources or good getting started type things. Or I mean, I guess at
Yeah.
a certain point, like I learned it from having the amphour.com and other websites and just messing things up over and over and over again. And like 2 a.m. in the morning, just like being like, what is the matter with WordPress? But
Wow, that sounds exactly like how I learned it too.
yeah, right, right.
I mean, yeah. So I unfortunately, like, I'm really, really bad. Like, seriously, everyone listening to this, never ask me for book recommendations. Don't ask me for website recommendations. Because I just like break stuff, and then I just cycle around and keep
Mm-hmm.
trying until I fix it. And it's probably really inefficient. But what's nice about doing it that way is you make mistakes and you end up learning all these tangential topics while you go along, versus
Mm,
if you had like a really structured book that you're kind of following through. What I've
mm-hmm.
found with that is students, they walk away learning what the book taught them to do, but like there's all these details, like all these like fun little things that they never discovered,
Oh yeah.
so So I don't know. I mean, it's other people can, defer to other people for
Okay.
that sort of stuff.
Okay. Well, I will have future ones, I'm sure. But yeah, I think Twitter's a good place to go for that sort of. Twitter has a lot of downsides, right? But I think I saw one thread on there that was a while back that was like, what are some shell commands that people might not know that are like really useful? And it's like, holy, like, you'll learn stuff on there after using Linux for 15 years to be like, oh, that's what they were doing? Like, like just tab completing and, like all that stuff.
Yeah. I saw a great like PNG that was shared, or PD. No, it was a PNG. It was just a picture, and it had like just a whole bunch of shell commands that every Linux user needs to use, and it was floating around on Twitter a couple weeks ago. And what's funny is like I've been using Linux for years and years and years, and I still learn some things, right?
Yeah,
and what's funny is like you start to so you know this, right? You and Dave were talking about specializing versus kind of being a generalist. For me, my Linux stuff is super specialized to building embedded Linux stuff, right?
Right.
So what's funny is there's like entire areas of Linux that I just don't know anything about, like especially like user space stuff. Like I don't know, someone's like, oh, you're kind of a Linux guy, right? I'm like, yeah, I mean, yeah, kind of. And they're like,
I kind of more just make people systems so that they can do stuff on it. Yeah.
Well, and that's the thing. They're like, well, what software do you recommend for like for video, for playing videos, and like
yuck.
what like media center stuff? It's like I have no idea. Really don't know, And
Right.
that's kind of the other funny thing about so this post that I did, right? It's like as soon as I got to a shell prompt and I logged in, it's like, all right, done.
I'm bored.
Like I'll run a benchmark, and it's like, that's good enough.
Yeah. Yeah, right. And like, what else? I mean, at that point, if anything's broken, I imagine you could test all of the peripherals, make sure those are hooked up properly. But assuming that they are, then like, you don't need to like exercise them because
you're in application land.
Yeah, you're teaching the process. You're testing whether the processor is working as it's supposed to at that point. It's like I don't need to go find bugs for all winter or Atmel or whoever.
Well, and the funny thing is like so I would argue like once you're in user space, you're done with hardware, right? It's like so going back to that accelerometer example, right? I've added the driver to Linux. It probes properly. Well, I can just read it, right? It's an IIO device or whatever. So I can use some IIO user space library, and I can just access the accelerometer data from my C code or my Python, whatever, or whatever I'm doing user space code in. And what's cool about Linux is there's that super strong line in the sand between kernel space and user space. And so what's funny is it's like I'm working on a project right now that we I can't pick a processor, Chris. We started on a
Well, when you can put them all in there, Jay, I mean, that's, like basically it's like that study of like how many jellies that you have to choose from at the grocery store. It's bad. People are happier when it's 2 or 3.
I know. I need to just stick to one processor and use it everywhere. We started on a V3S. It's like, like I was prototyping these things, and it's like, first of all, that V3S, it is hard to solder. All
I don't, like what is the V3? Is that one that's in here? I don't remember by name.
It's it's an all-winner V3S. It's a 0.4 millimeter pitch QFP that's got like a gazillion pins on it. And I don't know, hobbyists, and Twitter electronic solder people, they always talk about, oh, they want QFPs. They want QFPs. It's like, no, give me a frickin' 0.8 millimeter pitch BGA any day of the week compared to that. Those 0.4, those things are horrible.
Elliot and Mike Stish were Elliot Williams and Mike Stish were talking about that on the Hackaday podcast last week after talking about your article, and they said the same thing. It's basically like Elliot was talking about like the spacing there, and it really is pretty sizable. Like between 0.8. But I will be honest, I don't do I mean, I avoid BGA. I think it's because of the visibility thing. It's like, oh well, I'd have to, pull the whole thing off. I don't know what would be going on, but
I love that. I love that. I love that you said that, because I was also talking to someone the other day who was talking about like, oh, I can never do those all that DDR routing because, my scope only goes up to 150 megahertz. So I don't know how I'd ever see any of those signals. And I guess my thing is, if you have to, first of all, like if there's a short circuit on your BGA, you're done, right? Like, what are you going to do? Like, all right, let's say I give you an X-ray. Does that like somehow?
I actually do know some guys that did like a drill in Bodge, and there's people that do that, but it's like, it's so cheap to just make new boards these days, right? And just if leave yourself time in the schedule and you're fine then, right?
Yeah, and so I guess my whole thing is like, if you've got like a DDR, if you're really at a point where you've got a DDR bus and it's not working at all, and you think you need to break out a scope, then you probably you probably need to go back to the drawing board, because it's like the margins are just not that tight, I guess. Like soldering margins, DDR layout margins, everything is a lot looser than people think.
Yeah. Yeah. You had mentioned in your article about like using a higher grade memory as well, and then you get better timing specs on the actual DDR.
Yeah, yeah. And what's funny is even if you don't, I mean, you still have just oodles and oodles of timing margin. I mean, these processors, what I think what the problem is, right? There's these gatekeepers, and many of them are very well intentioned. And honestly, if you are doing this professionally and you're laying out these memory buses, you are probably using, DDR, 2600, 33, like crazy high speed DDR, doing DDR4 layouts. You're doing, 4 8-chip layouts with flyby topologies, and that stuff's all very cool. Don't get me wrong. I love it. That's great. I've done that stuff before. It's awesome. It's super. There's nothing cooler than seeing an 8-layer PCB come back with all these DDR chips. You carefully tuned everything. You got it dialed in, you plug it in, and it boots, and you do your MIM tests, and there's no problems. It works great. And it's like, it's awesome.
Yeah.
But I want everyone to realize that, if you're using these simple processors that have a little 16-bit wide DDR memory bus, you got a little DDR chip that's also a 0.8 millimeter pitch BGA, just try it. Like throw it on there. Like JLC boards are like $7 for a 4-layer board. We're talking $5 to $10 for a processor, $4 for memory. You're going to be out like, I don't know, 30, 40, okay, maybe $50, right?
And $50 in a weekend, right? I mean, like
$50 in a weekend. Yeah, $50 in a weekend, and you're going to have a computer, right? You're going to build a computer.
Right.
And it's just, and I guess the thing is, it's like, just try it, right? I mean, the absolute worst case scenario is like the DDR bus kind of glitches out every now and then if you like really screwed things up.
Right. Don't put it in a medical product or anything like that right now. Use your practice to try.
And just build stuff for fun, and that was kind of how I finished my post, where it's like, like you should be practicing. You should be building little breakout boards that do nothing, right? Right. I built 10 of these boards, spent 6 months, and none of them do a goddamn thing, right? They boot up and they've got a console attached, and you can run LS and CD, and you can run a dry stone benchmark, and that's about all it does at this point.
Right. It doesn't network. It doesn't. Yeah, it doesn't do all the.
It doesn't do anything, right? I don't have anything on there.
It's basically a fancy space heater,
Yeah, exactly. But what's great about these breakout boards is in this class of processor, every interface that you want to interface with, this can all comfortably run over 0.1 inch headers and wires, right? Just breadboard wires. Even like 100 meg Ethernet PHY. You're going to get some packet errors. Who cares, right? I mean, we have TCP/IP. This was designed for a reason. It can handle all this crap. There's CRC checks and all that stuff. Retransmissions. Like, don't worry about it. Just try it. Just build it, right? If you plug in an LCD, right, parallel 24-bit wide LCD, you got a 30 megahertz pixel clock running. Yeah, it's going to take 20 minutes for you to wire up all the signals from your breadboard to one of those little Adafruit, LCD breakout boards that they sell. That's awesome, by the way. I love that product. They've got this it's a little $10 dot clock breakout board. It's got the little boost converter for the LED backlight. And it's nice. Like one of those, there's all those like little discoveries that you make while you're doing projects like this. And so they you wire it up, and the absolute worst case scenario is that it kind of glitches out every now and then, but like proves out the idea. It proves out that, hey, this is how you connect it up. You've got, Qt embedded running on this thing. You've got touchscreen stuff working. And it's just, you've got a breakout board and all these kind of modules. And it's really just the next step. Like, I mean, if you got your little Arduino and you've got a little accelerometer and these little modules, and you breadboarded them together, it's just kind of you just turn up the volume knob a little bit. Now you've got, a camera, and you've got a parallel RGB LCD, and you've got an Ethernet PHY, and you've got an I2S codec, right? You can do the same sort of stuff that you're already doing if you're a microcontroller person. You just crank it up a notch.
That's right. Yeah. And I mean, maybe talk through the process of enabling that I2S bus, right? What do you have to do to actually enable that in the device tree, and like all the steps to do that? Because it seems like it's pretty minimal.
It's super complicated. What you have to do is you have to open up the DTSI file for the processor. You have to find the I2S line, and where it says status equal disabled, you have to change that to status equals okay.
That's a lot. I think I'll pass.
Yeah, it's super complicated, let me tell you. I mean, okay, obviously there's a little bit more, right? So that enables the bus. And then, if you happen to use the same audio codec as what's used on the reference design, then you're already good to go, assuming that you hook it up to the same I2C bus as well, because, right, a lot of those I2S codecs use I2C for configuration.
Yep.
But if you don't, right, if you use a different I2S codec, well, just enable it in your kernel config, your K config, your menu config, make Linux menu config, whatever, go through, enable it, and then add it to the DTS file and rebuild and copy the kernel over to your SD card, turn it on, and it should work,
Yeah. I mean, I think the mantra of just try it is like the most powerful thing here. And like, just because you can go build it and you can get reference designs as comparisons and all these things, I got to add this to my ever-growing list of things to try for sure.
And especially, I guess what I would say is the just try it really couples into, do it for fun in your free time, because there's nothing more stressful than having a client that you're trying to get a camera sensor going or an I2S codec going, and it won't frickin' work. And, the driver's broken in mainline Linux, and you found this other driver and this other Linux, and you're trying to port it over, but it's a 2.6 series kernel driver, and you're running, 5 series kernel. And so you've got to like update everything, and everything's completely different. And, that's stressful. It's stressful when like there's a job on the line, or, I would say it's even stressful when you have a project, even a personal project. Right. And like, so I have 2 students right now that are both, former students, because I'm not teaching right now, but they're both, they're still in college. This is their senior year, and they're both doing some embedded Linux projects. One of them's making a Nixie tube clock, but instead of just using like an Arduino or whatever, like, let's just do it with a embedded Linux system, right? So he's using the Nuvoton NUC 980, which is a 300 megahertz ARM9 chip, and it's in a 64 pin QFP. Like it looks like a microcontroller.
Yeah, that's awesome. Yeah,
it's hilarious, right? Boots off of SPI Flash, right? I mean, it's like if you can lay out a board with a ESP8266, you can lay out a board with this processor, right?
That's simple. One of the ones you'd written about that has a SIP as well, right? So that actually has memory.
Oh internal. yeah. That has it has internal, I think 64 or 128 megabytes of DDR2, DDR1 memory, whatever, some sort of DRAM. And, so what's funny is like, he's going through the process of, he's kind of up against the wall because, he wants to get this working, right? He's got this Nixie tube clock. He's got shift registers to control all the digits, high voltage shift registers. And, he put on some WS2812, the little NeoPixel, individually addressable RGB LEDs. Yeah. And I don't know, have you ever tried to drive those with a microcontroller?
Yeah, they're super tight timing.
They're weird, right?
Yeah.
So he threw them on his board, not really thinking about that, and just like hooked it up to a GPIO pin. So the funny thing is like in
Linux.
Like
you're saying, I see where we're going with this. Okay.
Yeah.
Right.
And so like that's like a great example of like, oh shoot, now what do we do, right?
Right.
And so he had to learn how to write kernel modules, right? Because a 300 megahertz processor is plenty fast to wiggle those GPIOs, but you can't do it from like a Python script up in user space. So he wrote a little kernel module that wiggles the GPIOs, and it's super simple, right? I mean, it's so you can use like GPIO calls from within a kernel module. But the nice thing is once you're down there, you get like nanosecond sleep.
That's
high resolution
300
timer.
Megahertz actually instead of
right?
when the operating system gets to you and
gets around to
it.
Yeah, exactly.
Right,
exactly.
Yeah.
So he actually built this kernel module, and what's the other cool thing about the kernel module is, you can load it really early in the boot process, and so he's actually got this thing animating while it's booting up. Right?
Nice.
Because he basically he just has a timer callback, right? He just registered a timer, an HR timer callback function. And so it just steps through to his next animation sequence, right?
Wow.
So his kernel module just has a periodic timer going, right? And no, it's just super cool. And it's like, it's just great. He's just trying things out. And I mean, so that is kind of an advantage of, doing like kind of a project thing where you're kind of up against the wall.
Yeah.
And
Self-imposed deadlines.
exactly. Whereas
Yeah.
I would just say, I don't really need to do that. I don't care. I'll go do something else.
Right.
Right. He's
Right.
like, I really want to get this to work. It's for my project. And so he rolled up his sleeves and taught himself how to do all this stuff.
I mean, that kid's gonna get hired real fast, I think. So that's I mean, that's a great example of like, having that kind of thing when you walk into an interview and be like, well, yeah, I built this thing, but here's all the stuff I know about it now. And like here's, here's how I showed grit and all that other stuff, right? Yeah.
Yeah, it kind of sucked. I had to teach myself how to do kernel module
Right,
development. It
exactly.
was kind of
And
lame.
then they slam a piece of paper with an offer on the table, basically. Yeah,
Yeah,
it's
exactly. And but the thing is like I don't want people to get scared away because like so I have another student who's like, he really likes music and audio and he's got these amplifiers and speakers laying around and he's got all his Spotify music and he wanted to listen to it. And any rational person would buy like a little Bluetooth receiver or like some, expensive box thing. He's like, "No, I'm just going to build a Spotify box." Right? Like I'm just
yeah.
going to build and it's 1 inch by 1 inch. It's built using a V3S.
Wow. Okay.
And like the V3S is the all-winner V3S. It's the perfect chip. Like you could not pick a better application because
I mean,
the
that's probably
V3S
what is inside the thing that you bought off Amazon that has
yeah,
Bluetooth anyways.
exactly.
I mean, like, yeah, it's like the
so
things
something
that
like
are
that.
being
Yeah,
used.
for sure.
Yeah,
Because like
right.
the V3S built-in Ethernet PHY, right? So you not
yeah.
just a Ethernet MAC, it has built-in Ethernet PHY. So you
Wow.
literally wire the Ethernet.
Hook it up to the magnetics. Yeah.
Yeah, exactly. You just
Yeah,
wire it
that's great.
straight into the chip, right? It's got
Wow.
a built-in audio codec. So no
Wow.
I2S crap. You just there's literally like left out, right out, headphone out, mic in, and
So
so
you put it into
it's
like an amplifier and then it just drives a
yep.
speaker and
Yep,
it's good to
yep.
go.
So he's got this little cube, and it's just got RCA outputs, and so you just wire it up into your existing amplifier. He's got some different amps laying around, and so he's working on that right now. And it's
That's
and
awesome.
this is kind of the opposite of the Nixie clock because like this is purpose built for all this. No zero kernel development, right? You literally it's all user space stuff, right? So he found there's an open source Spotify D project that is like a Spotify daemon. And
Oh, wow.
so,
Okay.
and it's written in Rust and he doesn't know anything about Rust, but they have precompiled binaries for ARM, right? For the Raspberry Pi, of course, is what it would have been for, but it's Linux, right? So this thing doesn't know if it's running on a Raspberry Pi or V3S or any other ARM chip. So he just copy and pasted the program, the executable program onto his SD card, ran it, and it just works great. No problem, right?
Wow. What is and so like then the networking side of that kind of example too. Like so is all the networking is kind of a freebie in Linux as well or what?
Oh yeah, because I mean Linux has the best. Okay, the BSD people are gonna slaughter me for saying that, but Linux has the best network stack
Yes.
available, right? Except for BSD.
People are passionate.
Yeah, especially BSD folks. No. I mean, right? You have the same sort of network stack that's running all the websites, all the servers, everything out there. Like you have that in the palm of your hand now. You're not relying on some weird proprietary TCP/IP stack that's got all these asterisks by it. For oh well, we support SSL. Except we don't do all this stuff, right? So
Yeah.
you just get I mean it's just and it just works, right? And so you can use network manager, you can just write little scripts that directly call ifconfig or IW or whatever, right? And because you're in Linux, so if you want Wi-Fi, right, on a microcontroller, if I had this existing system, I wanted Wi-Fi, it's like, ugh, God, this is a pain in the butt, right? You get like, you get like some ESP8266 that's got like a TCP/IP stack running on it, and you're kind of running these weird like serial commands
you use
to
a
connect
library and you just
in, and you
hope
got some
hope and pray, right?
hope that it works, right?
Yeah.
And in Linux, it's like, well, I'll just grab some SDIO Wi-Fi module off of AliExpress for 60 cents, like literally 60 cents.
Wow. Okay.
And, just whack it onto one of my MMC buses, right? And all of a sudden you are literally building, you're working at the same technology level that like a tablet, like an old tablet, a 5-year-old
Right.
Android tablet would use,
Yeah.
which is just SDIO Wi-Fi. And you just flick on the driver and it just works.
Well, this is a compelling case on all this stuff, but I'd like you to expand it a little bit broader, right? So now you're approaching a system. Say a client comes to you and they're like, Jay, I'd like you to design me a consumer device. It has to be $5. No, that's a terrible example.
Has to cost us $5.
Yeah, exactly. Yeah. Bomb cost. But
Yeah.
but in general, just like what is the thinking? You had talked in the beginning of the article about like you're seeing more and more applications for systems like this, and you've talked so far about embedded is maybe more hassle, but then where's your head at for when this fits versus a microcontroller versus I'm going to throw it in there, even though I know probably what your answer will be. Something like a Raspberry Pi 4 compute module like just got released, and so like kind of all the way through or even maybe above that, like a NUC or something like that, like an Intel NUC, like what or NUC, however they said, NUC. How do you decide what to actually put into a system when you're approaching a new problem?
I feel like we should have like a rapid fire, like you name the project and I'll tell you what to use. Because I think like the examples work way better than rules. Do you have any like give me an example of like what, like a thing? Name a product.
Name a product. All right. How about a I don't have any good. I should have prepared this, huh? Yeah. How about maybe if you have some examples that you built with, how about you just list them out and thinking about what you went through?
So like one thing. Let's say you are building a set-top box for like a TV, right?
Okay.
And something like that. You need HDMI, you need audio, you probably want some graphics acceleration. All right. All of a sudden, the Raspberry Pi compute module is 100% the first thing I would grab, of course, like hands down, right? You look at like
what specifically about it? So like because of the graphics?
Yeah. So let's talk about that. So like you look at like the IMX8, you look at, some of the high-end TI chips, and they can kind of stand in for some of that stuff, but they're going to be super expensive. The Raspberry Pi, it's, these Broadcom chips, they're built at super high volumes. So they're just generally low cost. They have all the graphics. They've HDMI transmitters built in. They've got graphics acceleration, video encoding, video decoding, hardware MPEG-4, H.264 decoding. And that's what you're looking for something like that.
Yeah. Yeah, because that's what they were built for. That's like where the Broadcom chip came from, right?
Yeah. So let's look at. Okay, all right. So
how about like a medical device now, or something that just has a screen but doesn't need that same level doesn't need to play that stupid bunny animation that every computer seems. I don't know what that is. Yeah. It's like some test animation or something. But
all right. So let me give you a good example. So I'm a big like sous vide immersion cooker
Great
guy,
example,
right? And so you've got you want to launch some fancy sous vide cooker that's got a really nice capacitive touch screen, all that sort of stuff. All right. Then all of a sudden things get really interesting. First of all, you have to figure out how big is the screen and how many pixels does it have. If we're talking like a smaller screen, something 3.5, 4-inch, range, something like that, maybe up to 5-inch, you're going to be looking at parallel LCD interfaces. So that's like a classic, like you've got literally a 24-bit wide bus that carries the pixel data. You've got a horizontal sync, vertical sync. You've got pixel clock, and it's just chomping away, right? And it's just this dumb, parallel RGB bus.
And that's because of choice or
that
cost,
is because
that is all you
what
can get?
People make. That is what people make.
Yeah.
Yep. That is just what people make. Now, newer displays are in that category are going to have MIPI. And so MIPI is sort of taking over. And the reason is because when you go into an EMC test chamber and you try to get your parallel LCD,
let's flip 24 bits at a time.
Yeah, it's awful. And I've tried it. And honestly, like, products that I've launched that have those parallel buses, that is where you get hung up. No problems with DDR memory, no problems with high-speed differential signals. All my EMC issues have always come down to 80 megahertz pixel clocks, to be honest. Like that's where you get your problems. So anyway, right? And there is a huge line in the sand right now. And what I will say is the processors I've reviewed, they're mostly older.
Mm-hmm.
All of them were launched except for the rock chip part that I reviewed at the end. They're all pretty old chip. Well, in the STM32 is actually brand new.
The MP1 is the newer one, right?
Yes, it's a brand new chip. But, all of them are like 2013, 14, 15. I mean, they're 5, 6, 7-year-old chips, which is eternity in app processor land, right? Consumer electronics. So here's a big problem. These older chips, they only have a parallel LCD interface. So if the display you're looking at is parallel LCD, then yeah, you can use one of these. But if it's a newer MIPI one, then you're going to have to throw all of these chips off the table. I think there's only 2 of them that I reviewed that have a MIPI interface, and that's the STM32 MP1. And that's also the, what was the other? Oh, the Allwinner, the A33 has MIPI.
Got it. Because that's a tablet type thingy anyways, or what?
Yep. And so MIPI is like your high-speed differential signal version of that same thing.
Yep.
Now, let's say that you go up and you've got a slightly bigger display. You're like a 10-inch sort of form factor display. Those are MIPI as well, but they also tend to be LVDS. So LVDS is also a differential signaling protocol, but it's it's a much dumber protocol. It's basically just like shift registers, I believe. It's super simple. And so, I think that opens things up a little bit. I think that there's, if nothing else, Chris, you can buy interface chips.
Yeah, right. Translations, that kind of thing. You could put the parallel.
Exactly. Yeah. That's tougher to do with MIPI. It's easier to do with a parallel bus. So do you see how like it's even like a product? You give me a product, and we were talking on the Contextual Electronics forum about that a little bit.
That's right. Yep.
Where you give me a very loose specs, and it's like even then it's tough. Even if you say I want an LCD, it's like, well, which LCD?
Right.
So like that really drives the product.
Yeah.
And so I would say that sort of stuff you can get by with sort of these entry level parts. What's funny, if you're not doing super weird 3D graphics or anything like that, what's funny is the CPU is not really a bottleneck in my experience, right? I mostly do, industrial control crap where you've got buttons and text.
That's right. Yeah, you're moving one line at a time, and you're selecting that line, and then it maybe re-renders a screen then, or something like that, right?
And so just to kind of prove that, because I think a lot of people get worried about that, I took one of the crappiest processors in my review in terms of CPU performance, the SAM9X60. We're talking about a 600 megahertz ARM 9. I mean, this is a 20-year-old architecture, right?
Yeah. Right.
And I just built the Qt 5 demos for it and ran it, and I recorded some video of that. So if anyone's curious, you can check it out. But it works pretty well. I'd say it's a perfectly reasonable experience. It lags a little bit every now and then. But, so I guess what I'm saying is I think for a lot of projects, it's not really the CPU that's the limiting factor. It's that display interface. If you need to go to MIPI or LVDS, all of a sudden, yeah, you might need to look at like an IMX8 or one of the sort of the higher end processors that I didn't review, because, those chips, they get to be a totally different category in terms of layout. Like the IMX8, for example, 0.5 millimeter pitch BGA for most of them, 0.65 for some of them.
Yeah, what I think about is like Robert Fahrenheit is teaching people with these chips. Okay, that's enough where it's like, okay, yeah, you're taking like an advanced layout course, and there you go.
That stuff is nuts. There's 12 power rails on that, right? And it's just and you've got 32-bit wide or 64-bit wide memory buses, and you want to actually make use of that, right? And Chris, if you want 64-bit wide memory, well, we only have 16-bit wide DRAM chips.
That's right.
So you're going to need 4 of those, right, to get up to that. So all of a sudden you got 4 DRAM chips that you're going to have to route an address bus to, and all of a sudden you're going to have to terminate the address bus. So all of a sudden, like at that point, get a SOM. SOMs are great for those high-end processors. Where SOMs make zero sense to me is for the type of processors that I reviewed. Because seriously, folks, like these things, you throw them onto a board, you route the memory. The student building a Spotify box I was telling you about, he's got another project, his actual senior design project that he should probably be spending more time on than his Spotify box. His senior design project.
Well, he's still a teacher in thought and action, folks.
So his senior design project, he's using IMX6. And that has external DDR memory. He's never routed this DDR memory bus before, but I was talking to him today, and he's like, I did the initial routing. It's like, how long did that take? It's like, it took a little bit longer than I thought. It took like 2 or 3 hours. It's like this is what we're talking about. Like, this is a 21-year-old kid who's a senior undergrad electrical engineering major. He's a great guy. He's super smart, but like, he's just getting going in this stuff, and he can route a DDR memory. I looked at it, it looked fine. It looked like it would
Mm-hmm.
totally work, you know?
Yep. Yep.
And so like, just, like that sort of stuff. If you got a single 16-bit wide memory chip, yeah, you can totally route that out on a 4-layer board, no problem. You don't need to buy one of these expensive SOMs, you
Yeah.
know?
Yep. Yep. That's what it comes down to.
And then as
That's
for like the NUC, like let's give an example there. Like the NUC, because
Yeah.
we kind of already covered.
So that's like a full PC effectively, right?
Yeah, yeah. And at that point, what I'm thinking is I need to do real deep learning. Not
Yeah.
like
Right.
real edge AI, not like phony, like, oh yeah, we're doing edge AI. And then you kind of look at their demos and it's like
Right.
they can do a
Right.
little bit of audio
Image
processing.
classification.
Yeah, like if we're actually doing like real AI where we've got like big convolutional neural networks, we need to forward propagate stuff at 30 frames per second. We need to do real time forward prop through this stuff. Yeah, you need a GPU, right? I mean,
Mhm.
and we are just so far away from like the computational, like, and that's the thing. People want to think that, oh, technology is getting better, these things are getting better and better and better. Yeah, and some of these parts, they're getting tensor processing units and they're getting accelerators. I'd say at this, like today, October 29th, 2020, I would say all of that stuff is limited to audio and very, very basic, I'd say like non-real time images,
You mean to use it on the parts that you've shown, or
Yeah,
to?
yeah, for like
Okay,
the parts that I've shown. If you wanted to do
got
like
it.
deep learning, I think that's really going to be kind of the cutoff. So
Yeah.
like, my research lab at University of Nebraska Lincoln, where I actually am a PhD student, technically, theoretically, on the side.
Right. Right. Well, like just when you're bored and you're not making, articles
Yeah,
and,
yeah, exactly.
working and all the other stuff, right? Advising people.
Yeah, exactly. So my colleague Eric Pasoda, he does animal tracking. He does pig tracking. To basically the idea is to improve the quality of life of livestock, so we don't have to use as much antibiotics. We don't
Hmm.
have
Hmm.
we better yields, and everything like that. And so he's really interested in automated tracking of these animals to look for like sort of occult behavioral changes over time to
Did
try
you say
to
occult? Like
yeah,
like a witch?
no, occult, OCCULT, like hidden, mysterious,
Yeah, that's
not
used in the
perceivable.
context of witches. Maybe I'm a little too close to Halloween
Oh,
here.
I'm sorry. I thought you said a cult, like a
Oh no, no,
space.
no, no. Like a witch. I said, yeah, like a
Oh,
witch.
oh, yeah,
Like
like a wit. Yeah, yeah, yeah.
yeah.
Okay, yeah,
Okay. Yeah. Yeah.
totally.
Okay.
We are totally on the same page. All right, all
Okay.
right, all
Cool.
right. So and so he basically has cameras recording pig pens, right? And he's recognizing all the features, the ears and the tails and the
Mm.
legs and everything like that, and
Yeah. So
tracking them over.
classifying them and seeing if they're healthy or if they look sick or if there's weird
Yeah,
behavior
yeah.
or
Well,
whatever.
I mean, even just like doing the tracking at first, and then
Oh
using
yeah.
that tracking
Okay.
data to then classify behaviors, right? And he has a farm of Alienware PCs with like RTX 2080 Ti's in them, right? Processing this stuff.
Real
So
space eaters. Yeah.
yeah. And so like that's when people talk about doing like, deep learning, right? That's what I think of. Like if you're doing like
Hmm.
actual hardcore real-time image processing, you're going to need real computers. And like a NUC is like a great place to start.
Yeah. Yeah. That makes sense.
Yeah, those are like your different kind of categories,
Okay.
of processors,
What
I'd
about
say.
what about going all the way down to the bottom then too? So now it doesn't have a screen, but like so then when do you pull out the if people don't know, Jay has the article about amazing $1 microcontroller. Those are kind of low end, but there are shades of gray in there too, where you might be running bare metal on, a higher end processor like a STM32F7 or something like that.
Yeah, that's a great question. And I think that's who that's where things get really weird. That's where 2020 is super weird. I was talking to someone on Twitter, I forget who, but we were kind of going back and forth about that, where it's like, this is the year where you can buy a 300 megahertz ARM 9,
Hmm.
right? From Nuvoton in UC 980, like a cheap Linux chip that's super slow. And you can also buy like gigahertz Cortex
Yeah.
M7s.
Right. Right.
And it's like, what is going on, you guys? Right. And so here's the thing, right? If you've got a microcontroller, I'd say the main thing is you're running microcontroller code. You're running bare metal code. You're using internal SRAM, right? And so you're
Yeah.
not using external DRAM. And all of a
Yep.
sudden, your low power capabilities are just through the roof. Like they're orders of magnitude better. Like embedded Linux systems are horrible for like sleep mode power consumption.
Yeah.
Like if you want this thing to go to sleep and wake up every hour, or whatever, like you're just going to get, if you need it to actually just wake up.
How about 100 milliamp sleep current?
Yeah. Yeah. And like these microcontrollers, you can get down to microamp, sleep current, even on like, nice high end parts. So, okay, that's one thing that would definitely steer you toward that. So if you're doing like some super high tech, maybe you're doing like audio AI processing where you're like listening for like a watchword or whatever. Yeah, is that what's, I think that's,
that's right.
like a watchword. Yeah. So you're like listening for a watchword. Then, you want to be asleep most of the time. And whenever, your audio codec hears like or your ADC like triggers, has a certain threshold that can wake up the system. And then you can actually, capture that data and analyze it. That's where like an M7 is a killer part. But here's the thing. You are going to have to be a fantastic engineer to get all that stuff working, because you've got an ADC, you're going to have to DMA that.
That's right. Yeah.
Into memory buffer. You're going to have to, you're going to have to port your TensorFlow network to bare metal C. And yes, there's libraries and stuff to try to do that. But I mean, just getting all that stuff plumbed together is going to be so much harder than running a Python script in user space Linux.
Yeah. 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 And I think about like Alicia and Chris kind of talking about like their unembedded. They're talking about like, when I think Chris talked about like putting stuff onto the Fitbit stuff, and like the amount of effort that it takes to like compile everything down and get it low power enough and optimize enough for like a tiny little device. That's not an F7 or it's STM32 F7, but it's so targeted and it's so low power that like that's really the only, you never run embedded Linux on that right now.
Yeah. Well, you don't have enough memory. That's really what it comes down. You don't have enough memory, and you don't have a memory management unit, right? Yeah, so you don't have separate address spaces for everything, which is
right. Which brings me another question then too. So now high-end microcontroller versus embedded Linux, but then when do you then switch down to an RTOS, like a free RTOS or Zephyr or something like that? Is that again in the power game? Is that the main consideration?
I would say that projects like Zephyr, which I have to warn everyone, I've looked at Zephyr. I've never even downloaded it and tried it out. So I'm definitely want to try it.
It'll rhyme. I think it'll rhyme with a lot of the stuff that you're talking about. There's kconfigs and DTS and all that other weirdness.
Yeah, because Zephyr uses kconfig. It uses a device tree system. Zephyr provides a hardware abstraction layer that's very similar to Linux's. Mm-hmm. So, I think, that's where things get really ooey gooey. And if you can notice, I am skirting around the question because it's tough. It's really tough to figure.
Yeah. You were talking about not being able to figure out chips before, and now you got to make these other decisions. It's like, you can do anything you want. And then now you got to go decide, and that sucks.
Yeah. And I think like Zephyr, so before, so Zephyr is like a big RTOS. Like it's a big thing. Let's pretend for a second, because Zephyr has thrown a wrench into everything. Zephyr has thrown a wrench into my thinking. Let's exclude it for a second. Let's say you're on like free RTOS.
You mean like big because a lot of like companies and a lot of SDKs
no. Big in terms of it feels a lot like Linux. Right. Oh, yeah. I mean, in terms of like how everything's plumbed together, the only difference, right, is it's got a single address space. But like, who cares, right? That's like a architectural design thing that, like nerds care about. But like when you're actually writing an application, right, like you don't really care.
I don't want to burst your bubble here, Jay, but the nerds are listening.
No, really?
They're also here too. They're in the room. They're in the house. Like,
are you talking about your dog again?
No, it's me. It's me here. Yeah.
Okay. I got it now.
Yeah.
No, I don't know. So like, but let's look at like a more classic RTOS, like free RTOS, right? Yeah. Which doesn't have the peripheral abstraction, right? It doesn't have, the network stack. I mean, it does have a network stack, but you end up mixing matching, right? So, so a lot of times with bare metal stuff, it's like, okay, well, I'm going to use free RTOS, but I'm going to use LWIP. I'm going to run it on STM32. So I'm going to use STM32 Cube. So I've got like my STM32 Cube GUI configuration crap that I'm kind of hooking up into free RTOS and da-da-da-da-da-da. And
it feels like free RTOS, like for an STM32 like that, it's almost like in user space. It's like you're putting an RTOS, but you're dropping in user space because there's nothing below it. It's just...
Yeah, exactly. And so in my experience, and I mentioned this in the post, in my experience, this stuff, it demos really, really well. You prototype it together, like you get your Ethernet PHY going, and the Ethernet MAC works, and you're getting packets, you got DHCP working. and everything seems like it's working. And then a couple hours later, it stops sending packets, and you go to like attach a debugger, and you're in like some hard fault. And it's like, what happened? How did I get here? And I guess in my experience, I just don't have that happen as much in Linux. So
interesting. Okay.
just because in Linux, right, your application, if it runs off into the weeds, Linux just kills it, right? And the system stays running. And, you might notice that your app crashes, but, you can dump it into a shell script and just do a while one loop and just keep re-invoking the app. Like every time it crashes, the shell script will just run it again, right? And I've totally seen commercial products launch that do that, by the way.
Wow.
And it's hilarious, right? Yeah. It's like, well, we think we got rid of all the bugs, but just in case, like just wrap it in a while one loop in a shell script, right? So again, I'm skirting around the question. I think I think it's harder to get reliable systems up and running. File systems, you want to do over the air updates. Networking is a big thing, on some of that stuff. I think Zephyr has the makings to fix all of that, because what Zephyr,
so it's almost like a FreeRTOS is like a half measure. If you're trying to get all these things, it's like, it has it, but like, unless you have the constraints, might as well just go all the way, you're saying?
Yes, FreeRTOS is a tasking library, right? I mean, it allows you to make threads and semaphores and mutexes and all that crap.
Right.
And that's basically the extent of it, right? Yeah, I mean, they do have an IP stack now, but they don't have like big libraries and everything like that. And again, it's like, I don't want to fault FreeRTOS, right? Because like I think I think it's great. I've certainly used it before. I've just noticed, and it honestly, Chris, I think it's mostly application. It's not so much FreeRTOS versus Linux. It's more the fact that you're writing, right? If people have never done this before, free RTOS, like an RTOS, right? Your everything lives in one memory space for the real-time operating systems that we're talking about. So you literally have like your void main loop has like free RTOS calls in it, right? To like start the scheduler, right? And you have little callbacks and little functions and everything like that. It's all one big app image. It's all one big cluster F word of code that that's all cobbled together. And so I think like when you're writing big applications, here I'd say one divine line, when you find yourself calling malloc a lot, right? When you're doing a lot of dynamic memory allocation, all of a sudden it's like, that's just a road to misery on microcontrollers. And Linux just seems like it works better because it can reallocate pages. The other thing is with Linux, you generally have a lot more memory. So even if you do have like a little memory leak here and there, it's less of an issue, at least right now.
It's a rounding error. It's a rounding error.
Yeah. So I don't know. I think that's kind of, I mean,
I like that. I think from a abstraction, I mean, obviously it is all abstraction layers, right? But like, I think it does the idea of like Linux being able to kill a task or a process to restart it. It's kind of like a nesting doll kind of thing, right? And you can kind of zoom back and say, oh, that's not working. I'll just restart it in Linux, right? But in Zephyr, you can't really do that. Or FreeRTOS, you can't do that. In like, if you're doing bare metal code, you can't do that at all. Like, you have your reset key. That's all you have, really. Like that's
and also think about if you've got multiple things that you want this thing to do, right? You want to do an over-the-air update every now and then. Man, in Linux, it's you just make a request to a server, download the image, check it against, I mean, it's a secure connection. That the image you get is going to be from that. If you've got your CAs are set up and your certificates are set up, and so I feel like it's just so much simpler. What I will say though is Linux seems like the obvious choice to people who know how to do Linux. And I know that sounds like a silly, like obvious thing to say,
like a truism,
right? Yeah, exactly. Right. But here's what I mean by that. So once you know Linux, once you know like the GPIO subsystem and I2C subsystem and, video for Linux subsystem and, ALSA and all this sort of stuff, man, it's just so fast to wire everything up, right? It's like, oh yeah. I just need to grab that library. I need to do this. But there are people that are just horrified at the thought of like compiling a kernel, right?
I'm one of them. I'm one of them. Yeah.
Yeah. And there's people horrified at the thought of like, and it's part of just how their brain, they just haven't rewired their brain. So it's like when they have like an accelerometer, right? And they want to talk to it, they think that they should write like a C program that is like reading registers from that I2C device and like doing all that stuff in user space. It's like, no, 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 no. There's a driver for that. Just flick it on. It'll work.
Yep, yep. Yeah, and that's an interesting point too, because like I think what the big switch then happens then is like once you're in this mode, you're like, yeah, gonna do Linux, gonna pull in drivers, whatever. And it's like I'm guessing that if you know you're building a Linux system, you would not design in a processor or sorry, an accelerometer that doesn't have a driver already in mainline or upstream or what, right? Like why would you do that? Like you could
Yeah,
just use it. It's just going, and then like that is the real benefit of it. And I had not thought about that before, but that's how I've been starting to think about it, at least with Zephyr and a little bit with some other projects. But like, yeah, why would you design other product parts in?
exactly. That's an excellent point. And I think that's what drives the decision making too, right? Because sometimes you want to so if I'm doing like a super simple project and I've got like some weird custom crap that I need to do, I've got like a lot of timing stuff. It's like, God, do I really want to like write? Like I'm gonna just be writing kernel modules. Like this whole project is just gonna be writing
Yeah.
kernel code. If that's all I'm doing and I have to test it and debug it, it's like, God, this stuff sucks. I mean, writing kernel code sucks. Like you can't just
Okay.
like attach your JLink and, like step through, because it's like you got a memory management unit. So everything's like remapped into weird memory spaces. So it's just like
So you like
development.
really set up GDB to really know where to look and stuff like that.
No, it's not. Well, yeah, you can try. It's like usually it's easier just to give up and just use printfs, and pretend that we
Oh
don't
wow.
have
Okay.
debuggers anymore.
Okay.
I think that's how a lot of driver. I mean, I don't know, right? So full disclosure, I'm not a Linux kernel developer, right? I don't.
Right. But it sounds like you're avoiding it for that reason, right? You don't want to go do that.
Yeah, I mean, and certainly, like I've written kernel modules, and I've certainly had to hack at them and get them working and everything like that. And I think that's kind of one of the issues, right? Are you someone who I think like when you get more experienced, you are no longer interested in just writing code, right? And the main thing, I guess, when you're using like free RTOS, right? When like you write so much code, and so it's simple because you understand everything that's going on because you wrote it all, right?
Yeah.
That's like what we were talking about earlier, right? With Linux, you spend all your time reading source code and trying to figure out why this code doesn't work, right? Or figure out how to use this code,
To
right?
be fair, Jay, that's what I also do when I write my own code. So,
But I think, I think about like microcontroller development. It's just a totally different thing, right? I mean,
Yeah.
like, something like an image sensor. If you hook up an image sensor to an STM32, right? So you configure the CSI, you've got your DMA going, you get a interrupt at the end of every line, at the end of every frame. I forget, I haven't looked at that stuff for a while, but you can imagine like literally in the DMA callback, like, okay, well, let's are we at the end of the image? Okay, if not, well, let's do another line, and like kind of writing these like basic kind of if statements, if else, and kind of going through, and then at the end it's like, okay, well, we got our image, let's copy it to here and reset the DMA pointer to some other address and do kind of some ping pong buffering thing, and then we'll call a little function to process the image, right? And you have total control. If the image is coming in as YUV 422, right, with chroma subsampled crap, I mean, then the first byte is your luminance, the second byte's your chrominance, and that, right? Because you wrote this code, you wrote every I2C register to that image sensor, you got it all set up, so you can go through and process it the way that you think it is, right? When you're in Linux, what ends up happening is it doesn't work and you don't know why.
Right.
And you end up just reading code and trying to figure out, well, and it's like, why is this driver not getting glued to this I2C address properly, right? And it's just stupid. It's just stupid stuff like that. You end up spending way more time debugging and way less time writing code, I guess is what I would say.
Yeah, but it's because you're the pot of gold at the end of the rainbow is it quote unquote just works, right? It just works, but it's a lot of stuff has been done for you. It's included, it's like you get these freebies.
And I think like if you're like starting out or whatever, you don't see that because your projects, no offense, tend to be pretty basic, right? On like microcontroller stuff, people start out making kind of basic projects, and they probably don't work that well. I mean, sometimes they kind of crash or hang or whatever, and you just hit the reset button and whatever, right? But when you get into it, you start to really value having a kernel driver for your camera sensor that always works. It never ever screws up. It never ever breaks. You always get a frame of video. It's always perfect. There's no weird corner cases. And you look at this driver code, right? And there's zillions of if statements. There's mutexes everywhere. There's, switch case statements, go-tos, error handlers, all sorts of this stuff. Like someone has got, not someone, hundreds of people,
multiple
thousands
people.
of people.
Yeah, I think that's the wisdom of the crowd kind of thing.
Exactly. They've gone through the source code and they've written everything. It's been tested. There's bugs that are being found in drivers that are 20 years old, right? New bugs that someone finds. There's like some weird corner case and they submit a little, send in a patch, right? And so you have the power of the human race in your source code.
Right. Yeah, it's interesting too because I read Jack Ansell's newsletter for a long time, and obviously he teaches a course on like bugs, and like he doesn't actually obviously Jack is like super focused on embedded, right? And yet he doesn't mention Linux in there that much, right? And it's like he talks about like errors and how often bugs happen and regular bug rates and how to remove them and stuff, but actually he doesn't mention that specific thing. And sometimes it's because I think some of the companies that are using them, they just don't. It's not the right application, right, to use a microprocessor with Linux versus otherwise. But like in that discussion of bug generation, which I am a bug generating machine personally,
like all humans.
Yeah, exactly. Right. But it's like, that would be a great balm for that potential, wound, I would think.
Oh yeah. I mean, it all comes down to surface area, and you want to minimize the surface area. Like you want to minimize the original work that you are creating, right? I hate to say that, but you want to write as little code as possible, because every line of code you write is like possibly going to be buggy. So just minimize the amount of code, right? So if you can build an entire system by, screwing around with some DTS files and grabbing some open source, program that, works and whatever, then it's the probability is that you're just going to have a much less bug-ridden environment. The problem is getting all that stuff going the first time is awful, and getting like the BSP going is awful. Like, do not get me wrong. Like, I do not want to, underestimate this stuff, right? If you have like a little microcontroller, you've got a little SPI display, you grab some library, you grab your Adafruit.
I was going to say, like, that's a great comparison too, because like a lot of people make decisions based on like, does Adafruit have a library? Does Spark have a library? It's like, and then just buy that thing. Like the equivalent is, at a higher level is like the Linux side of things. So
yeah. And so for those libraries, like you kind of grab that library, like you will get it working faster, than your first time on Linux, where you're trying to learn all this stuff. There's just so much to learn. But here's the thing, that upfront investment that you make in learning all that, what it means is like these days, like if I've got a new project, like I'm working on a project right now, freelance project where I don't want to go into this.
That's okay.
Not for confidentiality, just because it would take way too long to explain the whole thing. But for our purposes, all you need to know is it has a display, it has an Ethernet PHY, it's got an audio codec, and it's got a camera. And it's got NFC, and it's got USB-C power delivery crap, right? All that junk. And, man, doing that on a bare metal microcontroller, like that would just take forever to get going.
That's a lot of stuff, right? Yeah.
And with Linux, like I will say, I sat there one afternoon and I grabbed, actually we're using one of the parts that I reviewed, the IMX6. I sat there and I breadboarded this whole thing up, right? I just plugged in a camera module, I plugged in a display, I plugged in Ethernet PHY, just a mound of breadboard wires, and uncommented some stuff out in the DTS file, enabled some drivers, and turned it on, and everything more or less worked. I had one problem with the Ethernet PHY because I had not connected a pin. But that was literally like out of the 50 pins that I had to wire up, right? One of them's disconnected. I missed one pin, hook it up, and we're off to the races. We're receiving packets, and think about like all the user space debugging capabilities that you get, right, when you're in Linux. So that's kind of the other thing, right? So like, all right, I've got my camera wired up. How do I know if it works? If I'm on an STM32, what do I do? Right?
Export packet by packet, or frame by frame rather. Hopefully it
over like
good.
UART, and then like write a Python script to read that. Man. On Linux, you just run like a little GStreamer command or whatever, save it to a JPEG file, double click on, copy it over SSH and open it up on your desktop. Hey, I got a picture. Look at that. It works. Let's say you got an I2C device that's misbehaving. Linux has I2C tools, right? You got these user space tools. You can scan a bus. You can see all the devices on it. It's like, oh, it has an address 30. I thought it was 15, right? And yeah, so it's just like there's so many great debugging capabilities there too. But it's really, Linux is best for big systems. I would really say like it's where you start mixing things. It's where you need Wi-Fi and a camera and Ethernet. Because the other thing is like it's just some of that stuff is very, very complicated to do on a microcontroller. Like seriously, if you wanted to do Wi-Fi on anything other than a microcontroller that has integrated Wi-Fi, how do you do that? I mean, it's kind of gross.
I think you bit bang a pin at 2.4 gigahertz, and then you put an LC on the end, and am I saying that right?
Yeah. There's a Hackaday article, I'm sure, about that.
I'm sure there is. Yeah, I'm sure there is.
Some FPGA bit banging 802.11. Right. Yeah, why not?
Yeah. Do you ever do systems where you're mixing and matching? So like you run a Linux system, whatever, but then there's like a supervisory microcontroller that is low power and shuts the whole thing down, or
all the time? Yeah, that's a super common design pattern.
Yeah,
and maybe not even in that role. Definitely in like safety critical stuff, right? I mean, but I will say, I mean, app processors have watchdogs, right? You can certainly have a watchdog timer that is completely independent of everything, and it can kill Linux and reboot it if.
Actually, I meant like for a low power shutdown. So like your Linux system, your screen's on, it goes off. You don't want it to be in sleep mode on Linux. You want it to be like off, and then the micros there watching for a button push or whatever, something.
Yeah. No, that's a great example of where you would use that. Another one is wherever you're doing controls, right? I mean, a lot of times like, do I really want to like write a kernel module and try to do this stuff? And even then, I mean, kernel modules can be preempted, right? I mean, everything can be preempted in Linux. So you are not guaranteed to be able to bit bang your way out of a problem, right? And so, one advantage of a microcontroller is, and so the other thing is like, think about just different skill sets too, right? If you've got a goofy peripheral where you've got a lot of weird GPIO crap and and you've got to kind of bit bang this weird protocol, but you got to, do it in response to this ADC event, or you're doing, think about like motor control, you're trying to do like center line.
How about that? How about the WS2812, like you mentioned before, right? I mean, like some weird.
Yeah. No, that's another great example, right? Yeah. But like if you're doing like motor control and you're trying to do like center line PWM where you're, sampling your ADC on the middle of that to get, motor current to do field orient control, and you're doing this on 20 kilohertz PWM, like, no, that's not, you cannot do that on
what if,
like,
what if you have a packet coming in? You might need to know that next packet's coming in, Jay, from like the Wi-Fi, like
exactly.
Oh, I have an email.
Well, and that's a funny thing, right? Linux will gladly context switch to go get that packet and let your motor like burn up and catch on fire so you can download that email message.
Yeah. So you might create, so you'll take something off the amazing $1 mic. You'll take the LB one, which by the way, thank you for that article. That I love that part.
The EFM8. Yeah.
That thing's a sweet little part.
Just don't tell Alicia and Chris because it's an 8051.
Oh, I've told them. I've told them. They don't like it. Actually, what I did is I was asking them about, like, hey, I can't instantiate a variable inside a for loop here. And they're like, and then Chris went and looked. He's like, yeah, because it's using a C90 compiler. That's from the 1990. You're using a compiler that's 30 years old, Chris. I'm like, oh, okay.
That's what the 90 means.
Right, exactly. I was like, oh, I didn't know that's a thing, but yeah, that's apparently C90 does not have a for loop. You got to put the variable up top. So I know that now. So so if you're constructing a system like this, you have really, really high end or high processing kind of screen handling, all that other stuff. And now you're talking down a little microcontroller. What's your normal connection between the two? Would you just set up like a SPI bus between them, or what would you do there?
SPI or I2C are both super great. I hate UART because you got to roll your own protocol.
Yep.
You don't get packets. I want packets, right?
Right.
So SPI or I2C are definitely great for that. If you're doing like higher bandwidth stuff, people are going to shoot me, but USB is actually not a bad choice.
Yeah, I guess it's free in Linux, right? "Quote unquote" free.
Oh yeah, everything's free in Linux, right?
But then on the I guess you use that other EFM8 part, right? You like the UB1? Is that the one?
Yeah, yeah. I mean, I wouldn't use that for here because I
Oh, yeah,
think it
because you
was
said high
12
capacity.
megabit,
Yeah.
12 megabit per
Yeah.
second, full speed USB with, you're just gonna have too many, overhead, too much
Uh-huh.
overhead. But if you had like I don't know, like a lot of higher end ARM parts have, well, not a lot, a few higher end ARM parts have a USB high speed
Mhm.
PHY built in.
Got it.
And many other higher end ARM parts have like a USB peripheral, and then you use an external PHY.
Mm.
I don't know if that's like a great solution. Really, at that point, I would be looking at like an STM32 MP1 that's got a built-in Cortex M4 microcontroller that's just part of the chip.
Right. Or also the, AM335, the BeagleBoard,
Yeah, yeah, the
processor too.
AM335
Yeah,
that has the PRU.
that's right. Yep.
For sure, for sure. Because what that lets you do is you have shared memory, right? And there's nothing faster than shared memory.
Got it. Okay. All right. So, and then that would drive some of your specs you're saying, because maybe you have the specific requirement of real time, whatever. You wouldn't go and switch down to an RTOS. You would just have this real time element that's in there that's crunching on code and spinning and
Yeah, and I
handling
may
stuff.
even run an RTOS on that microcontroller, but yeah, you
Oh,
could
wow.
still
Okay.
have Linux doing it too. And like and really, I don't wanna make people think that like RTOSs have no place. Like honestly, like if I were like, let's go back to the sous vide thing, right?
Hmm.
It's an LCD, and I need to control a heater and a little pump, or like a little thing that's mixing the water around,
Hmm.
and I need a temperature sensor, right? I mean, you can definitely do embedded graphics on microcontrollers, and I do that all the time. So I'm not saying I would use an embedded Linux system for like a sous vide immersion cooker, or like other like sort of white good consumer devices that are like, in other words, like as soon as you have a touch screen, it doesn't mean, oh, you need to run Linux, right? What I'll say though is, you just look at the ecosystem overall. And like GUI toolkits, for example, on embedded systems, they tend to be very expensive
Hmm.
or crappy.
Yeah.
Like the free ones are okay, but they're pretty
And
bad.
they're ugly.
And
Yeah.
then
Your
yeah,
client's gonna
and
be like,
then
"Oh, that's that. Oh, look, Comic Sans, huh?"
yeah, yeah, exactly. They're ugly and they're hard to use.
Yeah.
And then the commercial ones, they look beautiful. They're super performant, but they're also like, I mean, you're going to pay 10K for a
Yeah.
license.
Right.
So you have to figure out like, what's that 10K worth to you? Is it
Hmm.
worth, if you already have some embedded Linux experience, is that 10K that you're going to spend on licensing, if it's a low volume product, right? All of a sudden that 10K, that
Buy a
might
lot of
mean
chips for
something to
that,
you.
you know?
Yeah, exactly. Right. So if you're looking at a $10 Linux system or a $5 microprocessor system,
Hmm.
depending on the volumes, it might make sense to jump up to Linux.
And then, so you're saying in Linux, then you'd switch to like a Qt5 or something like that, or
Yeah,
yeah,
yeah. Or there's many, many, many to choose from.
got
And
it.
what's funny is even the the bad ones that I was talking about, a lot of them have Linux frame buffer support. But because all of a sudden you're in Linux, you can have threads that are real threads, and you can have real malloc and everything like that, and they just work way better.
Mm,
Like, so even like the crappy ones, they just feel a lot less crappy once you're running on an application processor. But
interesting.
it really depends. I'd say like memory allocation, man, well, and I say this in my blog post, I should have just echoed what I literally already said, which is, I think it really comes down to memory allocation. Like if you're doing a lot of mallocs, if you're moving memory around a lot, creating memory, destroying it, doing a lot of stuff dynamically, look at Linux.
Hey, give it a shot, folks. Come on. Give
Yeah,
Linux a
yeah. Just
try.
look at Linux, and I hate describing it like that, because it's like a very like nitpicky minor. It sounds like a very technical thing, right? Most people
Yeah.
don't think about like, oh, how many malloc calls am I
Right.
currently doing my application?
Right, but
But
you're
really, I
thinking
think
about it in
that's what
terms
it
of
comes down
pain.
to.
You're thinking like, hey, I know I'm gonna have to clean up all that stuff. I'm gonna have to deal with it, and that's where a lot of that's when you start overwriting bad places.
Yeah, yeah. And like going back to your point, like throwing a $1 microcontroller on a board is super trivial. And you throw it on a SPI bus, you throw it on an I2S bus, and it
Mhm.
just works. And it's really easy to send data there. You can write a little kernel module if you want to get fancy, that exposes a character device or something. But I mean, at that point, if you might just do it in application space too, and in user space, and just communicate directly
Mm.
to your microcontroller. And then, yeah, your microcontroller, it could run like a little PID control loop, right? It could run, other things like that. One project I'm working on, I'm actually working with a friend of mine who's a mechanical engineer, electronics engineer. He's kind of a do everything,
Mhm.
firmware, electronics, mechanical, just crazy, crazy guy that does everything. He doesn't have like a ton of Linux experience. So we split up this product. It's got a motor in it and some mag sensors and some other things like that. all that stuff is being done on a little STM32, right?
Yeah.
And so he's got that. He's writing all the firmware for that, and he's just got like an I2C device that that I talk to, and I just say, "Oh, go do this."
I'm just
Go do that,
imagining
right?
Jay like at the meeting where he's with his friend and just being like, "Oh yeah, I guess I'll spend all my time on the Linux stuff. That'll take so long. You go design, you do the STM32 stuff, and I'll be over here
Oh,
with
he
Linux."
spent. Oh no, I mean, yeah, no, it's funny you say that, but I mean, he spent way more work because he's doing all this mechanical CAD stuff.
Oh no, that's exactly what I meant. I meant you had the, because you're good at this and because you know how to do it. You're just like, oh,
Okay, yeah.
you feign the idea that it's going to be a long time, but then you're kicking
Oh
back
yeah.
and having a beer. You know.
Yeah. No, and that is what's great about it, right? That's awesome.
Yeah. All right. So I'm gonna get yelled at if I don't ask some of the questions because I asked so many people for questions. So let's go through some of the Reddit questions some of our listeners have submitted. Has any of the vendors contacted you to use these as dev kits?
No, and they shouldn't, because these would be very, very bad. Like these are not like, and people have asked for like me to release PCB designs and schematics. Here's what I'll tell everyone. If you want to design one of these parts, hit me up. Like seriously, like show me what you're working on. I can do like a schematic review. I can help you kind of look for issues. But these are not good boards. like I cheated in so many places. Like my AM335 board like barely comes up like the first couple revisions of it, right?
Yeah, and we should say too that you said it was like you have 10 total processors you did, but you built 35 boards, so that's an average of 3.5 boards. So that's, you know, he is human, folks. He's human.
Yeah, no, and it's and that's the thing, right? I mean, and some of it was like just to play with it, right? So like, you know, so I had like my IMX6 board and it was, you know, properly length tuned and everything dialed in perfectly. And it's like, what if, right? Because you're always doing this commercial work, you know, and you don't want your revision A prototype to not work. So you always tick all the boxes, you know, cross all the T's, dot all
Put
your
in
I's.
all the zero
So you always
resistors.
length tune everything, right? and you know, yeah, you go through the process of length tuning it and getting everything right. But what I wanted to say was like, all right, what happens if I literally delete all my serpentine routes? I'm doing no length tuning at all. I literally just connect the DRAM chip to my processor, and just however it's connected, that's just what we'll go with. So I ran a second version of that and tried it out. And of course it worked just fine. No problems at all. Right. And I repeated that on the Allwinner A33 board. I just didn't length tune it at all. And I was really pissed because it worked perfectly fine. I ran like MIM tests for days and I didn't get a single bit error.
Oh my God.
And so it's like, okay, I need to break this. So I realized I could overclock the memory bus speed, right? So this chip is only rated for DDR3 800. So that's a 400 megahertz bus. Well, let's just run it at, I don't know, twice the speed. We'll double the clock, right? And so I bumped it up to DDR3 1600. So we're running at twice the rated speed that this chip's guaranteed for on a non-length tuned bus, right? Horrible, you know, stupid bus. And I still can't get a single freaking memory error.
Wow.
So yeah. But what I will say is vendors, they shouldn't use my designs, but what they should do is they should follow this form factor. They should realize, hey, these boards, these chips, like we were talking about earlier, they don't have any super specialized high-speed peripherals. We don't have crazy MIPI stuff that needs, you know, specialized routing or connectors or anything like that. So what I want to see is dev boards with 0.1 inch headers for every pin. Keep it simple.
You're
just
saying they think they're too good for they want to put the Samtec connectors on there. They want to make the interface boards and whatever.
Yeah, they put all of these, you know, what it's really designed for. It's designed for people who write code who are like allergic to breadboarding things.
Sure. Yeah.
And I just feel like there's a lot of people that don't fit that category. There's a lot of people that really just want to like hook things up to their own modules and verify everything, right?
Yeah.
And so the problem with these dev boards that they have is you've got to buy their LCD module because it's got their connector on it. And all of a sudden you're really limited to your project. So yeah, that would be my suggestion for dev boards, but no one has hit me up yet.
Okay.
Next question.
What CAD package do you use?
Altium.
Okay.
Altium Designer 20.
Great. And so I guess you've already kind of answered this because it's like people are like, oh, well, I need a high-end package to do perfect length matching, but nope, wrong, you know?
No. Well, and like, you know, like look at KiCad these days and it's just getting crazy. Like it's so good. It's getting better and better and better. I still think like so personally, I'm just way more productive in Altium. I've played with KiCad a little bit. Part of it is just my lack of knowledge, but also I still think Altium's a lot more productive than KiCad at this point. So if you're trying to do something really, really fast and you know how to use Altium, use Altium.
Yeah.
But here's the deal. If you're in KiCad or Eagle or whatever, you know, Adobe Illustrator, and you're going to try to like, I don't know. I mean, you could basically use anything you want. Like it's not a big deal.
Yeah. Yeah. Great. Okay.
Especially look at the SIPs, you know, and they've got the memory built in, and you know, then all of a sudden you don't even have to route a memory bus.
Yeah.
So
exactly.
Yeah.
Yep.
Hook up power, ground, reset pin, hook up your SD card. You're good to go.
Okay.
It'll boot. Trust me.
Great. What does this say? There's someone from the Occult Informatics Lab says hi. I am kind of creative, the Reddit user says. Okay. So you've already talked about that. Since I graduated, it looks like
who?
I am kind of creative. There's just a username on Reddit, so that's the downside. So this person asked how you're doing.
I have no idea what you're talking about.
So I'm on Reddit.
I have no idea who that person is.
I don't either. I don't know. This is just a username, you know, like this is a generic.
Oh wow, okay,
anonymized. So
you should hit me up.
I am kind of creative. The person, the username /u/I am kind of creative should hit up Jay to say hi.
Cool.
Okay. What core elements do you try and address in the class that you used to teach? And as embedded systems change, where do you see intro to coursework going?
So my intro class is, well, we're completely switching gears now. All right, context switch. So my intro embedded systems class, so we're talking about microcontrollers now, not Linux stuff.
Yep.
So my intro embedded systems class is what I want students to do when they leave the class is the fundamental theorem of embedded systems is peripherals are memory mapped. Like, and that's really sort of the fundamental theorem. So we start out, we block diagram systems. So I want them to be able to actually design embedded systems when they leave. Yep. So we actually, I call it the embedded corkscrew, where we're kind of like circling around through different topics, and we'll come back to things time and time again. So, you know, we'll talk a little bit about GPIO, but only at like a very high level, right? We'll talk like on the first week of class, we talk about GPIO as a way of getting digital signals, you know, in and out. So we kind of give examples of turning on a light or a switch or something like that, right? And so that's kind of what they know about GPIO then, right? Week 2 or week 3, like we've talked about some other topics. We're going back to GPIO. Now it's like, okay, how do you actually do it on a microcontroller, right? And so how do you get a pin to go high or low? Then later on in the semester, we'll actually talk about like output impedance, and we'll talk about, you know, input impedance, and we'll talk about that sort of stuff, push pull versus open drain, all that sort of stuff. So I teach embedded systems with like a sort of heavy electrical engineering perspective, because I'm in the ECE department. So I teach electrical engineers.
I think I mentioned on the show, but when I heard you talking about, so this is also what you talked about in your second appearance on Embeded FM, which we'll link here. When I heard this, I got so mad because my intro to microcontrollers class, Jay, was someone who didn't want to teach it. And then he's like, you know what? We're going to learn J2ME on a Nokia brick phone.
What?
It was so bad. It's been 15 years. I am still mad about it. It's like, I just overloaded the mic. Sorry about that. But like, I was so angry about it.
Oh my God. That is awful. What?
Like, how do you, I should have like asked for my money back. Like that's not a microcontroller, you know, like
that's not a microcontroller.
It's so bad. And it was so poorly taught, and it was just such a shit scenario.
Oh man.
And when I heard this, and like, this is exactly the kind of class that I wish I would have taken. Is this online anywhere or anything like that?
So I have a side project. I haven't talked about this at all. So I guess kind of news announcement. I'm working with a friend. I want to build a web-based interface for my online reading class, because my intro class, it's reverse classroom, so all the lectures were online, but it's through our like learning management system and blah 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 blah. So I'm working on putting together like a platform where everyone will be able to learn embedded systems,
like without hardware or with hardware.
Without so it'll be reading assignments, everything like that, and there will be a lab component so you can follow along and do the lab. Nice. You'll be able to buy.
Oh, okay. So you have like actual piece of hardware, but it's at home kind of thing. Yeah.
Yeah, exactly. So this is designed like I thought about this during COVID. There's so many labs that are shut
Yep.
down,
Yep.
universities, everything's online. So I want to give people, both university students and then just anyone interested in this stuff, just a way to do that. And I want to make it free or very, 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 very cheap.
That's
Kind of
great.
exploring some different options there.
Cool.
And so hopefully that will launch at some point in the future. It's one of the many projects I have on my table. But
Yeah, you have a lot of
yeah, so it's
projects. Yeah, it's
yeah,
a lot, a
yeah.
lot.
I try to stay busy.
Yeah.
But so yeah, with intro embedded, right? I mean, what I love is the first week of class, right? First day we're like, or second day we're block diagramming systems, right? So it's like one day I have them go into groups and they divide up, and one group they want to make an electric drill, like a battery, like a cordless drill. It's like, all right, well, where how are you going to do that, right?
Mm-hmm.
And so they kind of have a trigger, and the trigger is like they say, oh well, it should be a potentiometer, it should have like a analog voltage, right? And because when they get to my class, they've played with Arduinos. We have like a freshman
Oh yeah, like a
intro electrical
auditing
engineering
course kind of thing.
just like a
Yeah.
fun, they build like little robot things or whatever.
Yeah, that's
And
great.
so they kind of know a little bit about this stuff, but so it's like first day of my class, they're block diagramming stuff, right? And so it's kind of top down. Like they haven't written a single line of code. We're not talking about anything. It's like, let's block diagram systems, embedded systems, right? And then what's funny is then I jump way on the other end of the spectrum. I get an 8051 out and I open up a hex editor and I write like 6 bytes to it and I program it and the LED starts blinking.
Nice.
And the 6 bytes that I wrote out are the instructions for move,
Yep.
Move a value into some GPIO peripheral, right? And so we kind of go through that and look at that. And, when I was planning the class, I thought, man, they're going to hate this. They're going to get bored out of their brain during that lecture, but I need to do this. And maybe some of them will stay with me and they'll see it. Everyone was at the edge of their seat. They were just glued to this. They were just amazed that like, this is how a computer works.
Well, like you look like a magician at that point, right? You're basically like, oh yeah, all that code and all that tool chain, even for an Arduino, which is relatively simple. You got to do all that stuff. How about we skip it? Like.
And it's exactly. And it's like at the end of the day, this is a machine that reads bytes, decodes them, and executes them.
Yep.
And so they need to understand that. And so, I brought in like old 8051s that have like, the sapphire window in them. And you do UV programming, right? Or erasing and everything like that. Right. And of course, like I drove a clock signal with a square wave generator. Right. And so you kind of slowly ramp up the clock and you see that LED blinking faster and faster and faster. I hook up an LED to the clock. And I have them count the number of clock cycles that it takes. And it takes 24 clock cycles to do this move instruction, another 24 to do it again, and then another 48 to do the jump, right? Yeah. 2 cycles to do the jump, right? And so they can see that this is like, you can think of microcontrollers, they're processors. They're these mechanical machines, ticking along, and processing a byte, decoding it, executing it, processing it, and so we kind of start there. By the end, we're using code gen tools and doing I2C stuff, and it all worked up to a DJ light. We had this off-the-shelf DJ light. I redesigned the control board for it to use a PIC 16, which we were using in class. And they programmed it. And the finals day, everyone brought in their disco light, and they showed everyone what they had made it do.
That's awesome. Yep, I'm very excited to hear about that online platform. That's going to be really great.
It'll be great.
Okay, let's keep going. Which of the 3 PinMux tools, NXP, TI, or ST, did you like the most?
I don't know. They're all fine. The ST one feels like it should be the best because it's like Cube, STM32 Cube. Yep. It's exactly the same interface and it feels like it should be good. The problem is it doesn't actually generate all the stuff you need. Oh. Like it generates like the PinMux it generates the PinMux code, and then I think the peripheral init code, but there's like other random crap in your DTS file, like your console UART and some other things like that. And it doesn't generate that stuff. I don't know. There's like some technical details. I'd say maybe the NXP one, they're fine. The TI one's fine as well. Here's the thing though with DTS files. Most of the time, you're just going to uncomment out some existing DTS code, right?
A lot Instead of starting from scratch, you're going to use the dev board and already has it there, and you're like, oh, enable this, disable this, right?
You got it.
Yep. Okay, cool. So this person has a IMX6 ULL series and they've successfully brought a board to life. Since I now have a working base I can work upon, after what complexity point should I consider using this embedded Linux system in a project?
I guess I'm not sure.
So it sounds like they did a equivalent kind of thing where they brought it up, they got it working, and now I think they're saying
Yeah,
like
yeah,
is
yeah.
this verified enough to push it out in
Uh,
the world as a product into a product that they're building?
I mean, that's complicated, right? I mean, you need to do like, if this is a product, I mean, it needs to go and do EMC testing.
Hmm.
You need to verify the hardware actually does what you think it's doing.
Well, the other things that are in this question too is about like what's on there, right? So this is kind of what we referred to earlier, right? There's a GUI, 800 by 480 touch LCD, defined filling status. So like basically, this is a system that measures whether liquid propane cylinder is full from a load cell. So it sounds like there's a load cell input, there's an LCD, there's a GUI, there's touch screen, all that other stuff. And so it sounds like the same kind of thing of like peripheral
I
matter.
think I understand the question. I think what the person is asking is, all right, here's like maybe a project that I'm working on. I've got this IMX6 board. Should I try to use it in this
Yeah,
project?
exactly. Yeah, and like kind of defining the boxes. Like I think about this too. Like so to use that EFM8 LB1, like the laser bee that you talk about, and I started using. I think about it now, and I like, okay, what would I throw that? What project types would I throw that at? And I think
Mm,
about it, and it's like, yeah, it's a tool in my toolbox now, but like it's not a great fit for everything. It's more like, oh, low level code and maybe some analog stuff. That's really what I would use it for, versus like go learning a new part, honestly, or
yeah, yeah. So I mean, yeah, if you're monitoring things, liquid propane. That sounds kind of safety
sure,
critical.
yeah.
But okay, with all that said, I would say, yeah. I mean, give it a shot. I think the big thing, it kind of goes back to what we were saying earlier. If you have a deadline, you have a client screaming at you, and you've never done Linux before, it can be really really scary
Hmm.
because something doesn't work and you don't know why, and it's not your code, and it's hard to debug this code. So at some, like, when you're getting started, you kind of cross your fingers and hope that all the peripheral drivers work properly and they do what you want it to do. I will say, if you've got an LCD, a parallel interface LCD, his peripheral list that he said, I'd say it's a go. Like, do it. Yeah,
Got it. Yeah.
the IMX6 is super super stable for that sort of stuff. Where I've had issues with IMX6, camera sensor interface. There's two drivers in the kernel right now that are floating around, and they're kind of different, and you have to pick one, and it's the device. It's kind of goofy, but
Yeah.
the whole media framework in Linux is kind of goofy and weird. So
Okay.
as long as you're not doing camera stuff, I would say like the IMX6 is great.
Yeah, it's almost like we need like a. Here's another project for you, Jay. Uh, it's like
Okay.
having like all of these things are basically Venn diagrams, right? Or like it's like one of those heat map charts, right? Where like does it fit in the cost versus the power, and like basically they're all overlapping circles. They're like these heat maps of where these processors might fit into different applications and
Yeah,
all
that's
the
a great way of
peripherals
looking
that
at
are
it.
there. But like having something like that just helps to decide, or like a site that would help to decide this sort of stuff. It's like at the end of the day, this is why someone hires you, right? But you
Yeah,
know,
yeah, for sure. And what I'll say is, and the big caveat, I'd say, so as soon as you get past I squared C, let's say parallel LCD interfacing, SPI, Ethernet stuff, I squared S, like the camera sensor and any other like kind of specialized peripheral, I would verify before I trust the part.
got it.
Like, and that's one of the great reasons about great reasons to build a breakout board, right? Build your breakout board, try the camera sensor, try the weird peripheral that it says it has, and actually show yourself that it works and that it
Yeah.
actually works. Because vendors are, vendors are notorious for bragging about things that don't actually work.
Yeah, well, we had our intern write the code, so it worked that one time. So
Yeah,
it's,
yeah.
it's in the SDK now.
Yeah, it's like trust but verify,
That's right.
right?
Yeah,
With Linux, it's always trust but verify.
got it. Okay. On the phone, or sorry, on the camera side of things, someone asked, any luck interfacing with current smartphone cameras? It's about $20 for the best camera module on a flagship smartphone, but interfacing proved to be a challenge.
Yeah, yeah. So Yes, I've definitely done some of that. We talked about that a little bit earlier.
Mm,
So all those sensors are going to be MIPI. They're all going to be raw, so they're
got it.
they're not going to give you your image data. So you're going to need a processor with an ISP, image sensor processor, whatever they're called. Basically, you need a hardware
It's like a
block that can do
block. Okay,
demosaicing,
got it.
chroma, all that sort of stuff.
Got it.
That's so none of these chips would do that. There's very few chips that do that. You're looking at high end, very high end, like TI automotive chips that you have to sign NDAs to get.
Right.
Otherwise, you're looking at honestly consumer
Yep.
chips out of China, rock chip and all winter,
Yeah.
right?
Yep.
So it's funny, but like that's the Venn diagram, like rock chip, all winter, and super crazy automotive grade TI processors are all in a category somewhere,
Yeah.
you know?
Or I mean,
It's
if you
weird.
can buy the higher end stuff, you could maybe get into, some of the Snapdragons and all that other stuff that's out,
Yes.
like
Yes. Yep.
basically anything that's in consumer. But then how does this all play into so you mentioned a lot of these chips are from 2013. They're still being made, but I'm guessing it's because they found other homes. Whereas I imagine that like a Snapdragon 890 or whatever the hot new thing is, there's no guarantee that that's going to keep being made in 4 years from now.
That's a great point. Yeah, those consumer chips, they tend to go away. I'll say like what's funny is everyone craps on these Chinese chips, they're here one day and they're gone the next. Allwinner really has a pretty
Mm,
good track record
yeah,
of just making things forever.
right. They're making money. They don't care, right? They're going to keep
Yeah,
making. Yeah,
yeah.
yeah,
And I think it's a good point that you make. I bet like the A33 that sort of started out as an Android tablet processor.
yep.
Today, if you tried to put Android on it, oh man, it'd be awful. It'd be so
I
slow,
actually
so
still have a
bad.
tablet that I use for like reading sheet music, and it's
Hmm.
it's like a 5 minute boot time, and a lot of apps don't work on it anymore. But who
That is
cares?
so funny. I have exactly the same. I have a Samsung Android tablet that I use
Yeah,
for sheet music,
yeah, yeah.
and
Mine.
it's awful.
Wait,
It's
is it?
absolutely awful.
Wait, I don't actually know if mine's Samsung. Mine is actually the one where like remember when they used to put 18650s like in the one side of the tablet, so it has like that
Oh,
huge
wow.
tube of just
Oh, wow.
18650s. Yeah, it's that.
Whoa. So that's like really old.
Yeah,
Okay, yeah,
yeah.
mine's not that old,
Yeah,
but yeah, yeah.
it's not much runs on. It
That's
still runs Chrome, which is kind of all it needs. So, but
yeah,
it's slow.
yeah. Runs like Android
Oh no,
2.
it's a Motorola. It's a Motorola. It's a tablet. Yeah. So
Oh, cool.
yeah. Okay.
Very cool. Very cool.
Let's see what else here. Here's an interesting one. Do you see embedded Linux combined with something like EtherCAT or Modbus TCP as a viable replacement for PLC machines?
Texas Instruments sure does. They make that AM335,
That's
and
right.
that's basically what that's designed for.
That's right. Yeah.
So yes.
Seeing lots of beagle boards inside of industrial equipment or equivalents.
And yes, and that's about the only thing I would use an AM335 for, would be something like
Got
that.
it. Yeah.
Because it's built, it's purpose built for that. It's got dual gigabit max. It's got a Ethernet switch built in. It's got those PRU
Hmm.
real time units that are kind of goofy, but hey, they can run a protocol. They can run an EtherCAT on them. Do
Hmm.
it. Go for it.
Yeah. Yep. And so you're saying that like because I mean, and would you run graphics on that, or would you just kind of do it headless and handle all the data and then push it back to another A33 running on a interface unit, or how would you do that?
I would have to think a little bit more about the application. You could
Mm.
definitely put no reason not to put a little touch screen on there if you wanted
Yeah.
to.
Okay. Cool. How much did you use a dev board before you making its own board for applications requiring some connectivity, either USB, Ethernet, or wireless, but not much computation? Are these chips a good option?
How much did I use a dev board? Like
Yeah.
before I made
So
these.
like when did you pull the trigger and start actually like doing the layout?
Mm, so for a lot of these chips, I don't actually own a dev board for them. I link to dev boards for all of them, but I don't
Mm,
actually own dev boards for most of these.
got it.
One of the reasons why I did this was so I could end up with a bunch of breakout boards for these processors because the dev boards are quite crappy. I wasn't a big fan of
Mm,
really most of them. I think the Beagle board, that's a great dev board. That's basically
mhm.
exactly what you would want on a dev board. Some vendors, they really try like this weird Raspberry Pi form factor, which I thoroughly shat on in my review. The STM32 dev board
Oh yeah, you
is
said
awful.
why didn't you just put it in like a Nucleo, right? Didn't you say something like that? Yeah.
Yeah, look at ST. They have they make literally the best
Yeah.
dev boards for their processors, for their
Right.
microcontrollers.
Right.
They go to make an embedded Linux chip and, oh, well, we should make it look like a Raspberry Pi so that the hobbyists like it's like and it's just gonna
That's
just
probably
think about how
exactly the conversation that had happened in a conference room, like.
and just think about how disappointing it is. You get your STM32 MP whatever, the $60 dev board, right?
Yeah.
That's twice the price of a Raspberry Pi, and then you plug it in and realize, oh, it's a 650 megahertz like single core Cortex A7 or dual core Cortex, right?
That's right.
Like this is not a fast chip.
Hey guys,
right?
I'm going to make my media center just like Raspberry Pi told me to.
No,
it's like,
no,
you're not.
Oh, I don't have a video encoder. Oh, okay, or video decoder. Yeah, no, and so the problem is, it's like, first of all, it really sucks as a single board computer, and then the other thing is like, this is
why is that though? Is it because not enough breakouts or peripherals stink?
Oh, well, no, as a single board computer where you'd want to attach a keyboard mouse monitor.
Oh, got it. Okay.
Yeah, like when I say single board computer, I definitely mean something that is designed as a computer. Like I want a board, like a Raspberry Pi is a single board computer, right? It is really designed to plug a keyboard mouse monitor into.
As anyone who tries to boot one without a monitor or a mouse, it's like,
exactly.
You better get that config file right, or you're going to be rewriting your SD card a bunch.
Yeah, I mean, well, and like lots of things are that way these days. Like, so I got an NVIDIA Jetson TX whatever,
TX2,
something like that. And and I did that in the middle of this whole review. So like I just, I look up the UART, plug in the USB to serial on it and turn it on. And like I don't get a prompt. And it's like, what is going on? And then I'm reading, oh, you have to plug in an HDMI connect. It's like, I'm not set up for that, right? I don't just have like an HDMI monitor laying around. I had to go dig up a USB keyboard. And it's just like, this is so clunky. Like just give me a UART and give me a console over, UART. And like, that's what I want. So like, yeah, with the STM32, like the reason why I get so mad about this stuff is this is a fantastic embedded Linux part, right? This thing's got a built-in Cortex M4 or M4 microcontroller. It's got literally, it's got the peripheral set that matches the highest end STM32H7. So you've got like 22 communication peripherals. You got zillions of timers and ADC, right? This is like the craziest microcontroller ever. And oh, by the way, it also has two 800 megahertz Cortex A7s and can run Linux.
Wow.
Right? In addition to just being a crazy microcontroller.
Right.
So I got super excited about this. I bought the dev board. And $60 or whatever. And yeah. And oh, sorry, you can't actually use the LCD because we routed, right? You can't even hook up a parallel LCD to this thing because they routed all the pins to the HDMI transmitter on the. It's like, what would you use an HDMI for in an embedded Linux system? It's just not. It's not a very commonly used interface. And of all the I/O on this thing, only a subset of it is actually routed to pins, any pin. So yeah, really not happy about that. The other dev boards are classic, what I'd call like classic microprocessor dev boards, right? Classic embedded dev boards where they're just loaded down with connectors, right? This chip has a CAN bus on it. Well, we better put a $2 CAN transceiver on it and a $3 terminal block and all. It's like, God, you just end up with, and that's why these things cost $500 because I mean, they're not making money. They're not making much money on it. He's like, this is just what this stuff costs.
Well, I feel like sometimes they do it. They do it to keep out the looky-loos, right? Like that is one reason, but not the only reason. Yeah. This stuff's just expensive.
Yeah.
Well, 0.1-inch headers it is. Yeah, that's great. Let's see. Hard real-time Linux for safety applications. Why is it a good idea, and why is it a terrible idea?
There's like got to be some embedded Linux talks that I'm just going to slaughter this topic. But yes, Linux you can put it in, there's a real-time, it used to be a patch, I believe. And now it's actually just an option in mainline Linux where you can flick it on and it completely changes the scheduler and it no longer uses like a standard sort of preempt. It just uses, I think, like just a basic round robin scheduler. At that point, yes, it should work. But here's the problem. Generally, if you're doing safety critical crap, you've got to have a whole bunch of certification and all that sort of stuff. So I work at Virtual Incision. We make medical devices. And so everything's got to be ISO 619766341 compliant with, right? Your MISRA C and all this sort of stuff.
That's fun.
And Linux, like general Linux doesn't have that stuff. You can go to I think like Wind River, or some of those other companies that make like commercial Linux that carries those certifications if you want it.
Can you get around that by like segmenting systems for in your specific like medical example?
Well, we don't use embedded Linux, so I'm not sure of all the kind of regulatory entanglements.
No, I actually meant like skipping past that entirely and just saying like, hey, this part of the system safety critical. This is running MISRA C and all the important ISO stuff. And the screen doesn't matter.
Yeah. Well, and also like, what's interesting is you can do a lot of like end-to-end testing too, right? I mean, so as long as basically you lay out your product specs and as long as they're met and you test them and the FDA, agrees, then yeah, you can use it.
Mhm.
So, I mean, there's medical devices that run on Windows, right? I mean,
That's
which we
right.
don't
Yeah.
think of as like a, particularly safety critical operating system. So it just, yeah, I mean, you can make it work, right?
Yeah.
And I think like I wouldn't have any issue doing hard real time, like do a real time Linux kernel. Yeah, sure.
Okay. I think we'll make this the last one from the crowd in case I have any others. But how good are different silicon vendors about upstreaming their kernel patches? And are we better off relying on the kernel folks for the most part? Kernel forks, their kernel forks, or the kernel folks.
The kernel folks that make the forks.
Yeah, right. The fork folks.
Yeah. Yeah. So I'm tiptoeing around in the sort of huge, vast swath that is the Linux developer community. And yes,
Tell me your feelings on Linus. No,
I mean,
just kidding. I don't care.
he's,
It's fine.
yeah, he's insane. Yeah.
I just feel like
Yeah.
anytime like the Linux community comes
Yeah.
up, it's like someone's gonna bring it up, someone's gonna say it. So, anyways,
Well, the thing is, yeah, I mean, the thing is, it's like I feel sort of I have a little bit of imposter syndrome after publishing this because I'm getting like messages and people like from the maintainers, right? Like the people that are in charge of like the entire subsystems, that some of these parts, saying, oh yeah, you should also look at this, or you should look at that.
Oh yeah,
And it's like there's this huge world of developers, and some of them are on Twitter. But here's the thing: all the crazy people that are really good at this, they keep to themselves, they keep their head down, they're super focused on all this stuff, and you're never going to hear about them, unless you're on the kernel mailing list,
right? Or you watch the repo and you're like, oh look, a change.
Yeah, exactly.
Yeah.
So okay, but answering the specific question, yeah, I mean, it really depends on the vendor. I'd say most of the vendors are pretty good. I would say like of the parts I reviewed, all the sort of like mainstream vendors that you recognize are good at this. I would say like the Allwinner stuff is, so that has, what's funny is that all has like really good mainline kernel support because it was done by just third party just people, right?
Yeah. They're
And
like,
what's
I want
interesting
this tablet to do this thing that it's not currently doing or whatever it is.
yeah, that's actually where a lot of it comes from. And what the other funny thing is, you will see so much code contributed by consulting firms where I'm a company, I need to get this LoRa chip working on my Linux board and I need a driver for it. So I need to hire a consulting company to write this driver. Of course, it's GPL, so they have to upstream it, right?
Yep.
Or they have to release a source code and it eventually gets upstreamed. So it's interesting to look at the commit messages. A lot of this is not necessarily from the silicon vendors. It's a lot of the peripheral drivers and stuff are actually written by third-party companies.
Right.
I'd say overall the Linux source code it's good. It's messy in places, but from what I've from the little that I've worked in it, I would say that the main vendors are decent at upstreaming things, and you shouldn't generally have issues.
Can you explain the process too of like what an upstream is? Because I feel like that's, if people are coming in, they're like listening to this and they're still listening after 2 hours and they're like, oh yeah, I still am interested in Linux and I have no idea what it is. What does that mean to upstream a kernel patch in that case?
Well, okay, yeah. I mean, so I guess think about it like this. Let's say you're making, I don't know, like a free RTOS project on a microcontroller, right? And you download free RTOS, free RTOS, you set it up, you configure it, you get your code working. Let's say in the process you make some changes, right? You now have a different version of free RTOS than what you downloaded, right? And the question is, what do you do with that? Do you put it on Git? Is it like do you have your own little version of free RTOS that has like your changes?
Yeah,
right?
I think the big one is when the official one changes, then what? I feel like that's the big question too, because then it's like,
yes,
oh, I got to maintain this shit,
And how do you synchronize it and all that sort of stuff? So here's the thing: if you've never thought about that, you're probably working on projects where your code is sort of like frozen in time and you kind of started with some specific release or even just, master branch at some particular moment in time and you've sort of hacked at it. And now you've got these two divergent versions of this, right? And you probably don't even think about it like that. But when you get into Linux land, what you realize is there's lots and lots of patches, right, that you're making to this stuff. And what's really annoying is when you're working on like some 4 series kernel that the vendor provided you, and all of a sudden you want to use some sensor, some brand new sensor that came out, and it's not in your kernel. It's
Yeah.
in a different
Yep.
kernel. It's
Yep.
in like Linus's kernel. It's in the current, what we call like the current mainline Linux, which is Linus's kernel. Like it's literally like this guy has a branch, right? On, you know, he has a Git repo, and you can go download Linus's kernel. And that's what we talk about when you say mainline.
Yep.
And then so what you think about is like there's all these other kernel developers, maintainers, right? So there's people that maintain like the ARM SOC subsystem for Linux, right? So they have kernel branches, right? They have their own Git repos, right? And so you think about like, let's say I find a bug in, I don't know, the IMX6 camera sensor peripheral, for example,
Sure.
right?
Yep.
Well, you know, I would submit that maybe to like the Freescale, NXP, the NXP guys, and you know, because they have their own kernel, and you know, and they could then submit that, you know, up to the ARM. Or actually, it wouldn't
Yeah.
be ARM. It'd probably be Media, the Video for Linux, like the Media subsystem maintainer, right? And so it will slowly work its way up to mainline Linux. And again, like this stuff, I'm tiptoeing in this. You know, I'm a hardware guy. I grab whatever works, and you know, I let the software guys sort of worry about
Sure. Yeah.
longevity and synchronizing kernels and everything like that. But yeah, it is an issue when you've got new features and you want to pull them down. Then all of a sudden you've got your version, you've got a remote version, and you need to somehow make them the same.
Right. Right. And I imagine that in the case where you have to write kernel code then, or like a kernel driver, then you're by definition, you know, you're going to decide like, oh, well, I got to have this one feature. I have it on my system. It may or may not go up to the top system, but then every time your software person pulls down a new version, you got to be like, did I break it? I didn't break it.
Yep.
Yeah.
Yep. And it's annoying to have these separate versions laying around, because what ends up happening is you've got generally what happens, you use a vendor kernel and the peripherals work fantastic. They've got all the features, all the, you know, let's say your LCD display, your LCD controller supports rotation, for example, right? Or it's got some fancy pixel pipeline thing that you can do, right? If you go to the vendor kernel, generally it has all those features implemented, right? You go to the mainline kernel, maybe some of those features haven't quite been pulled in yet, but the mainline kernel might have like, you know, better subsystem support. Whereas the vendor kernel, a lot of times they like kind of hack stuff together. They've got like a dev board with like a specific display or a specific sensor or something like that. And they've got their own little way of doing things. That's especially like, I would say like the consumer electronics chips, like the Rock chip stuff, the Allwinner stuff, they are notorious for doing that, for having like little hacks. And a lot of it, Chris, is just because Linux is slow to catch up to some of this stuff, right?
Sure.
So think about like when smartphones came out, and all of a sudden we have front cameras and rear cameras, right? So does Video for Linux have the concept of like multiple cameras, and you know, for front facing camera and a rear facing camera? Do you have like IDs? Is there any way to retrieve that information?
How do you
from
switch
Video
between
for
them,
Linux?
right? Like when you're
exactly.
into an app, right?
And because all of a sudden from your application perspective, you just see video 0 and video 1. You don't know which one's the front, which one's the rear. So imagine like the time it takes to plumb out the API to let you make a request to, oh, can you identify the cameras? Is the front facing, or, you know? And so generally, like, you know, the CPU vendors, they don't have time to wait for this stuff. So they just kind of do it their own way, right? And they've got some weird IOCTL, you know, vendor specific IOCTL call that you have to make, right? And then eventually that gets formalized into an RFC, and they actually implement it, and So I'd say that's kind of how things end up working.
Got it. It's interesting too. So what's your take on, like, so we talked about modules a little bit, but I saw one, I've been using a QuickTel module, so I'm on their mailing list, and they have a module that just like, it's like, hey, we got everything on here. It's got the processor, it's got the Wi-Fi, it's got all the hardware you pretty much need. You plug it in. It's like it's basically like a phone with connectors without a screen. And then it's like running Android. And so what's your thought on like Android versus this kind of thing? And then like, who would you think that targets in that scenario?
Yeah, I mean, I think what that targets is people who are Android developers, right? Think about all right, you're building an embedded Linux system. First step, you need a board support package. So you're going to be paying some consulting firm the $1 zillion an hour to put together this stuff.
Don't sell us out here. Come on, we're affordable.
Yeah. But like, you look at this. And the BSP work is like super hardcore, low level, crazy stuff. But hopefully you don't have to do much of that, right? All right. So you do a few hours of super high billable rate crap to get your BSP working. Okay, now your BSP works. Now you switch over to application. Here's a question. Do you want to pay someone, I'm just going to make up numbers. Do you want to pay someone, I don't know, 70, 60 bucks an hour to do like C++ Linux stuff? Or do you want to pay a Java Android developer, I don't know, 30 bucks an hour?
Right. Or get two Java Android developers for the price of one, right?
Exactly. So, I mean, at that point, right, that's where you look at Android. Here's my question, because I've never looked into this. How do you configure Android? Is it really easy to configure it to do single application startup, and you don't want all this crap running, and you just want it to boot up into your application? Yeah. Basically, I just want the core Android stuff. And I think there's like the AOSP version of Linux, and it's goofy. I don't know if they've done this, but I know they're trying to merge Android back into mainline Linux.
Oh, interesting.
Because Android forked, right, from Linux, like 2.6 or something, like ancient. And I think that they're either slowly integrating it back, or they're trying to merge it completely so Android will track Linux. I think that's on the roadmap. And then at that point, man, it just becomes like some packages that you install, right? And already you can get Android tools for Linux. So if you're in like build root, you can actually get like ADB, just tick it as a package, right? When you're building your root file system. And then you've got ADB. So you can actually use ADB to like remotely load and debug just generic arbitrary packages using the Android debug protocol.
Huh. Well, that's great. I mean, I guess it does. I mean, all of the target applications that I like kind of was looking through the app note for and stuff. It's like, display, like kiosks, all these different things, that kind of
it
stuff.
Would definitely be for that. Yeah. And here's the thing, Chris, like you and I, and you grab 10 engineers working on this stuff, and they have such different ideas about what they think of when they think of embedded Linux. Think about building, a kiosk, like something where I've got a touch screen and I need to interact, and it's like, it needs to like help people, like it's like a map. It needs to help them find, direction somewhere, right? Like that's so different than the sort of embedded systems that I make, right? Where it's literally, I need a TV that runs Linux or something, right? It's like so different than like some crazy custom hardware, and you got mechatronics and sensors and all this other stuff. Right. So, but like that's a huge percentage of especially low volume embedded Linux work that we see. So yeah, it's a huge area, and everyone's building different products.
Definitely. Last question I have is you're in Lincoln, Nebraska. You are a PhD student sometimes, it sounds like, at Nebraska Engineering. Why Nebraska? Is it just family kind of there, or what about Nebraska? You don't hear, I mean, I think there's an aerospace industry there, right? I mean, like what's around there?
Well, so Nebraska, like Lincoln is like primarily, I'd say, like healthcare. We've got like kind of a big healthcare and like, medical insurance and healthcare processing. A lot of that kind of like administrative healthcare crap would be like Lincoln's big
exciting
industry.
Those happy hours have to be really, really crazy.
Oh, they're great. Let me tell you. Lincoln, of course, is a college town. The University of Nebraska Lincoln has like a zillion students there that represent a pretty sizable portion of our population. There's not a lot. We have a small startup scene, mostly web app kind of, companies, business marketing, web app sort of companies. So I was born and raised here, nice. Family's here. Yeah. I always tell people Lincoln is a great place to live, but I wouldn't want to visit.
I think there's a Jim Carrey movie, I think, where like they're picking a place to go and they just like randomly pick Lincoln. So
yeah, it's great. I mean, it's like, it is a cute town. It is super, there's like tons of trails and parks, and we've got more green space than anywhere else. Like everything, we are just so insulated from everything, and it's awesome.
Insulated as in like real far away. Like people that don't live in the United States too. Like I mean, how long would it take you to drive to Chicago? It'd probably be like a 12-hour drive, and like that's
no, it's like 8 hours. 8
hours. Okay, sorry.
Yeah.
But I'm already still in the middle, and like then it's another, and there's
Oh yeah, no, for sure. So I'm not bothered by it because I live in my head, right? Like I'm not the guy that goes to all these conferences and is like hanging out with all these people. I know you're like a big conference guy.
Go to one that like go to SuperCon when that starts happening again. That's all you need to go to.
Okay.
You'll love
Once
that
once
one.
COVID,
Yeah.
I will say, like, with COVID, like, it has totally made me wish that I were a totally different person. Like, I've never been like big into travel and
Yeah.
all that sort of stuff, but I've just been itching to get out of my freaking house,
Yeah.
you
Yep.
know.
Yep.
And so no, what I'll say about Lincoln is it's I love it. It's a great place to live. It's a great place to work. Everything's cheap here. I can, these days I can take consulting work from anywhere. I've consulted for companies all across the world. It's not a big deal. It
Yeah.
really
That's great.
isn't. Everyone should move to the Midwest and live here for a little bit. It's fantastic. You're laughing, but it's
No, I'm laughing just at like
fantastic.
thinking about someone being like, "Oh yeah, that's a good idea. I live in San Diego right now. I'll move there. It's so cheap." And then like November,
Yeah.
we're 2 days away from November.
So it's early in the season, right? Where I
You're
still
still
am
optimistic.
I'm still romantic about like fall and winter, right?
Oh yeah, yeah. First snowfall. Oh, I'm like that too.
Oh yeah, it
I
was
saw the gentle
so
flakes the other day.
beautiful.
Yeah, it's really nice. And then
It's so beautiful, right?
gray, just gray for 5 months.
Yeah, no, exactly. And yeah, no, come January, like mid-January,
Yeah,
it's like, "Oh, I only have 3 more months of this," right? Because generally,
maybe.
like, by the end of March, early April, it starts to get, like, acceptably okay to go outside again. But yeah, no, it's not great for that. But we have seasons, and there's
We
something
have
to be said about
seasons.
seasons. There's seriously, there's something to be said about.
No, I know. Every time someone says that, though, I think there's a Daniel Tosh thing. He's like, everyone's like, "Oh, I love seasons. I love seasons." He just says, "Yeah, I do too. That's why I skip the crappy ones."
Yeah. Yeah. No, I mean, I think where I'd rather it'd be nice to live, a few longitude lines or latitude whatever lines
Yeah.
down a little
What they
bit.
really need is just the transporter. So you could hang out in Lincoln most of the year, and then it's super easy to get wherever you need to go, and you go back home, and then it's
Yeah,
like nice and
for
comfy.
sure, for
Yeah.
sure, for sure.
I know
Yeah,
these feels.
but no, I mean, so I work at Virtual Incision, medical device startup, one of the only hardware startups here. But here's the thing: I mean, we just got our IDE approval. We're going to clinicals. I mean, we've
Awesome.
got
Yeah.
millions and millions of dollars in investment,
Yeah.
and we can sell this company as we've got a small core team of engineers. We've got low
And
overhead,
all the
and
interns you
seriously,
need.
and all yeah, so many
Oh
interns.
man.
And seriously, it's like it's really not a bad place to be.
Yeah.
And I look at like all this stuff that's happening on the coast, wildfires,
Sure.
and
Sure.
all this there's political turmoil and
Sure.
unrest, and there's all this sort of stuff. And Lincoln, especially with global warming, I think Lincoln's going to be a really nice place to be in about 20 years.
Yeah. I
We're
had a,
gonna have lettuce growing,
yeah.
year round here.
That's great. That's great. Yeah, I had a conversation with a buddy in Rochester about that. Being near water, being near warm, or
Yeah.
it's not warm now, but it will be, unfortunately.
Yeah.
So,
I don't know. What do you think about Chicago?
uh,
It's kind of a halfway house
it's
between.
yeah. I mean, I like I moved here. I wanted to live in a city, right? I love cities. And I'm really excited I did, but like longer term, nah, not for me.
Yeah.
Just because like I'm in a lab space that's like I'm very lucky for the space that I have, but it's like Lincoln, you can probably get a pretty decent sized house and a great sized lab, and like yeah, that's great, and that's what I probably need longer term and that kind of thing. So I'm also like right downtown, so that's stupid on my part, but I like where I live, so yeah,
Yeah, for sure.
yeah, and also like every single value of a city during COVID times is gone. So if it wasn't for like
Yeah.
living walking distance from like a big park, it would be terrible. So
Well, and I think that like everyone is sort of like looking at their living situation, especially like all the people I know that live in cities, right? And they're looking at, I don't know, you can spend like in Lincoln, you can spend $250,000 and get a
5 bedroom house.
2,400
Yeah.
square foot house,
Yeah.
and like have dedicated. I mean, of course, I have a dedicated office, and I've got a dedicated guest bedroom.
Hmm.
My whole basement, I've got kind of a
You can have a
shop
basement.
down
That's also a
there.
thing.
Oh
So
yeah, and I'm coming to you from my beautiful living room. I've got
well,
vaulted ceilings, full of glass, mid-century modern
now
house,
he's just
right?
showing off, folks. Come on,
And
jeez.
it's like, and the thing is, it's like it's just ridiculous to think how much more money it would be
Right.
to have something like this
Right
on
in
the
the
coast.
Bay Area.
And
Yeah.
and the thing is, it's like if you are like kind of a loner solo person, that you are a homebody, like don't be a homebody on the coast. Like come to the Midwest. Like this is a great place to be a
That's right.
homebody
Yeah.
because there's literally nothing to do here.
Just go there and you work
Yeah,
more, and that's the Midwestern work ethic.
exactly.
Yeah, I do get a lot more done in the winter. I will say that. So
Yeah.
All right. Well, Jay, thanks so much. I'd love to have you back at some point. This was amazing, and please keep up what you're doing. These articles, like I said, I refer people to them all the time. It's just like such great reference material, and I really like what was the phrase you said? You said just try it. I think that's kind of that's the Jay Carlson method, and I'm real excited to hear what you do next.
Well, thank you so much. Yeah, it's been great talking to you, Chris.
All right. Well, find Jay on Twitter and jcarlson.net, and we'll have links for everything in the show notes. And thanks, Jay. We'll talk to you soon.
Thanks.
Today's episode was produced by Analog Life LLC and was brought to you by our patrons. Join the other patron sponsors at patreon.com/theamphour. You'll get a Discord invite to chat directly with all listeners of the show, and a special thanks today to our corporate sponsor, Vino.